Welcome, friends among the stars. You are here for a quiet crossing, a slow drift through facts and wonder. The ship is steady, the night is kind. Imagine yourself looking out from a darkened cabin. The window is a circle of red dusk. Mars turns below like a coal in deep ash. Ahead, a dim glow gathers. We are not rushing. We are watching with patient eyes as an interstellar visitor nears the orbit of a world we know well. So, before our journey begins, take a moment to like the video and subscribe, but only if you feel a genuine connection to the mysteries we explore here. Or, if you can, let us know your location and the time where you are. These small markers on the map make our quiet community feel closer, even across oceans and deserts. Now, dim the lights. Let the world outside fade away, and let's drift into the cosmos together. Main narration, log open. Com level 2. In this chapter, we set a firm hypothesis in the first minutes, then hold it to the fire of measurement. Title on the console reads, 3IATLAS nears Mars. Was this a planned arrival? Our first move is not to declare. Our first move is to test. The scene is simple. The orbiter slides into Martian night. The planet's limb is a thin ember, and beyond it, a soft smear resolves into a traveler from outside the sun's grip. We have seen 2 such visitors in our lifetimes. This is the third. A hyperbolic path draws a clean escape. It will not loop back. It will pass Mars at roughly 30 million kilometers on October 3rd. A geometry that places us in a privileged balcony seat. Instruments aboard Mars Express and the ExoMars Trace gas orbiter are cued to try their luck, to snatch a handful of photons while the visitor crosses the stage. The window will be brief, measured in hours, not days. The plan is careful. The tone is calm. The stakes feel quietly high. 2 hard facts anchor us before the mind wanders. First, the orbit is unbound. That is not a mood. It is a number. The eccentricity is greater than 1, so the sun's well cannot hold it. Second, our telescopes have already seen enough to sketch a character. Hubble caught it in July, a blue-toned image with a teardrop haze around a hidden core. The background stars stretched into thin threads by the telescope's tracking. From that stillness, we learned it is active already, not a bare rock, and that dust is leaving in an orderly way. The rest is inference, to be checked. Now, the bold hypothesis, stated with respect. If this arrival were planned, if timing and aim were chosen rather than granted by chance, then the evidence would leave fingerprints that physics cannot wash away. We would see accelerations that sunlight and venting cannot explain. We would see light that behaves as if modulated on purpose, not by rotation and jets. We would see composition or structure that argues for engineering rather than ice and rock. In short, intention must do work. Where there is work, there are signatures. Our job tonight is not to chase shadows. It is to line up the instruments and watch for the simplest explanations to carry the load. Many things that feel like intent turn out to be geometry and timing. Comet tails sometimes seem to point the wrong way because of where we stand in the theater. Polarized light can look strange when the grains are small, layered, or born in places colder than any cave of our system. The mind prefers stories. The data prefers patience. The coma deserves a close look. Early spectroscopy hints at an unusual balance, with carbon dioxide playing a leading role in the faint atmosphere around the nucleus while water lags. That is not unheard of for distant, cold comets, but the ratios matter. A CO2-heavy coma at several astronomical units suggests ices that wake at lower temperatures, which can make activity appear early and strong. If the green tint strengthens, that may come from familiar chemistry, often dicarbon or cyanide in sunlight, and the same pigments that paint other comets emerald near the sun. We will not assume, we will measure. What we can do from Mars is simple and effective. Imaging gives shape hints. Spectrometers on Mars Express and TGO can search for the fingerprints of water vapor, organics, and carbon species against a thinner background than Earth's atmosphere allows. Polarimetry, if we can manage it, can tell us about the dust grains that scatter the sun's light. If the dust behaves like the common comets, the polarization curve will follow a familiar arc. If it dives more steeply into negative values at small angles or flips at an odd point, we will note it and compare with models crafted for interstellar grains. A recent preprint reports exactly such an anomaly, a deep negative branch not seen in typical comets. It is tantalizing, not decisive. It's a clue to stack with others. There is also the question of brightness that rises in steps. Spikes in a light curve can be vents turning sunward, or fresh surfaces rotating into view, or bursts when crust fractures under heat. In a world eager for messages, those steps can look like code. Our counter is rotation period analysis, jet modeling, and the quiet math of sunlight pressure. If non-gravitational accelerations can be explained by asymmetric outgassing, they belong to nature. If something remains after the accounting, we will not rush. We will test again. One vivid image is worth carrying with you as we work. Picture the orbiter passing into the planet's shadow. For a few minutes, the sun is occulted by Mars, and the sky goes velvet. The visitor's coma brightens by contrast, a pale lantern against a field of hard, steady stars. The tail, or even the illusion of a sunward spike, becomes a thin brushstroke. In that small theater, with the red world hiding the sun, our sensors listen to molecules whisper. Carbon dioxide, water, maybe traces of carbon monoxide, each a letter in a slow alphabet that spells origin. A grounded speculation fits here. If the coma is CO2 rich, and if the polarization curve is deeply unusual, perhaps we are looking at an object that formed in a colder cradle than most comets we meet, with grains layered or sintered in a way uncommon in our Kuiper belt. That would make it alien in the strictest sense, not artificial, only born under a different sky. It would also explain why early activity looks strong and why colors can shift quickly as unfamiliar ices cross their thresholds. 2 more hard facts to close the loop for tonight. The pass by Mars is geometry, not rendezvous. 30 million kilometers is near for astronomy, yet far for intent. And the trajectory remains a clean escape. The sun will not catch it. We will have another look after superior conjunction, when glare fades and the object returns to a darker stage. The log stays cautious. The wonder stays open. If chance can look like choreography, what tests do we trust to tell them apart? And how will we keep our eyes kind while we ask? The cabin lights are low. Telemetry scrolls like quiet rain. A faint point swells by a breath, then another, as our tracker shifts from predicted sky to a live lock. The orbiter rides the night side arc of Mars. The limb is a charcoal curve. Space is clean and black. In that clarity, a third visitor from the deep between stars resolves from rumor into target. Log recording. We begin with position, motion, and light. The object sits where the ephemeris says it should, within a small handful of arc seconds. Its path is the clean signature of freedom. Eccentricity above 1. Velocity too high to bind. This is not a comet of ours on a long loop. It is a traveler passing through. The closest approach to Mars will be about 30 million kilometers on October 3rd. The window for our best geometry is counted in hours. Instruments are already stepping through their scripts, one after another, like a calm procession. Our first sequence is acquisition and rate. The object crawls a steady line against the stars at a pace that our guidance can follow without strain. Guiders measure a slow drift. The main camera rides the drift and stacks short exposures into a single, honest image, free of streaks. With that done, we search for a cue that says, this is not just a bare nucleus. The cue arrives. The profile is not point-like. There's a gentle swell, a coma that broadens the light. The outer rim is uneven, as if faint fans are lifting material away from the core. 2 hard anchors keep us from floating on adjectives. First anchor. The astrometric residuals are small and boring, which is exactly what we want at the start. The track we fit yesterday carries forward today without surprises after we account for sunlight pressure and expected outgassing. Second anchor. The brightness is up from last week by an amount our models allow when a rotating body turns vents toward the sun. Steps in the light curve can happen when a jet wakes, when crust fractures, or when geometry puts more reflective dust in view. We note the steps. We do not read them as code. We turn the spectrometer. The bandpass opens on a thin breath around the nucleus. The strongest lines belong to carbon species that tend to stir before water does in the cold. If carbon dioxide dominates, that would match early signs seen by other eyes. It would also explain a coma that seems larger than expected at this distance and phase. Water is still present, but if it lags, the balance of gases will shift as the object comes nearer to the inner heat of the system. For now, the mix paints a picture of Isis born in very cold reservoirs. A vivid image to carry forward. Picture the red planet's shadow sweeping like a curtain across the field. As Mars hides the sun, the sky around us deepens. The visitor's halo brightens by contrast. The tail resolves into two distinct behaviors. One stream curls away as you would expect. Another thin spike seems to point sunward. It is the anti-tail illusion, drawn by geometry and grain size and our line of sight. It looks like defiance of physics. It is a lesson in perspective. We pass a quiet threshold, polarimetric mode. The camera turns its filter wheel and measures the angle and strength of scattered light. On common comets, the curve of polarization versus phase angle follows a familiar shape, a shallow negative branch at small angles, a smooth rise with increasing angle. If our data dives deeper than usual into negative values, or if the turn comes too early, it may speak to dust grains that are layered or unusually compact, perhaps built in colder, slower places than the outskirts of our system. That would be alien by birth, not by design. Numbers cluster for a moment. Then we let them rest. The signal to noise in our first spectra is modest, but real. The coma radius we measure fits with a gentle gas production rate that rises each day. The rotation period estimate is rough, a few hours to a dozen, based on faint modulation in the light. We set reminders to test this against jet orientation later. We also schedule a short exposure during a Mars occultation of the Sun to see whether the coma hosts any narrow jets that hide in glare under normal conditions. A grounded speculation belongs here. If the coma is heavy with carbon dioxide at this range, then the surface may be coated with ices that release gas at lower temperatures than water. If that coat is patchy, rotation would make the light breathe in steps as fresh areas turn into sunlight. That patchwork, plus the anti-tail geometry, could make the object feel stage-managed to a human eye, even when it is only playing by the rules of chemistry and orbit. We do not ignore the provocative question that framed our mission log. Was this a planned arrival? If intention were present, it would have to move mass on purpose against all the small forces that also act. It would have to hide at work against the clean arithmetic of gravity, solar radiation, and gas thrust. Our first hours with real photons show nothing that demands such a cost. The line through our measurements is simple and patient. That does not end the question. It places it back on the shelf until evidence asks us to take it down again. One more image to end the pass. The orbiter glides over the limb, where day meets night. The visitor stands a little brighter now, like a distant lighthouse behind a thin fog. The planet below is quiet, gray plains edged by ancient craters. Between the world and the wanderer is a gulf that numbers fill with ease. 30 million kilometers is near for astronomy and far for intent. The distance is both a comfort and a clue. We log the next tests, a deeper spectroscopic sweep to chase faint organics, a polarimetric repeat at a slightly different phase angle to map the curve, a search for short-period flicker that could refine the spin rate, cross-checks with Earth-based observers once the relay comes around, and a plan for the hours around closest approach when our cadence will sharpen and our threshold for anomaly will narrow. A gentle question to carry onward. As the signal grows and our models tighten, what single observation would make you pause and admit that chance might not be enough? And are we ready to accept it if that observation never comes? Night, on the day side of thought. The cabin is quiet, the windows dimmed, and a pale line on the nav screen curves like a thread pulled taut across a black cloth. Mars turns below, steady and red. The visitor glides where the models said it would, a point that refuses to settle into any family the sun can keep. We start with the path itself. A clean hyperbola means freedom. In our fit, the eccentricity sits above 1 by a comfortable margin, which is the signature of an object that will not be captured. The shape is not negotiable. Gravity makes rules that do not play favorites. The approach to Mars is geometry, not rendezvous, and the projection shows a closest distance of about 30 million kilometers on a date already circled in every console here. The line that sweeps past the planet bends a little, as gravity always makes it bend. Then it straightens again and heads outward to interstellar quiet. There is a visual elegance to the numbers when they behave. On the display, we watch the predicted path and the measured path overlap until they are one stroke. Residuals fall into a narrow band. That is not a disappointment. It is comfort. The first duty of a trajectory is to be boring enough that anything interesting stands out. The interesting things we are alert for are small and specific. A steady drift that cannot be explained by light pressure or jet thrust. A curvature that keeps its sign after we account for all the known nudges. A timing offset that repeats with the object's spin. The first hard fact we put on the record tonight is a straightforward one. The object's sky motion matches a hyperbolic solution within the tolerance we expect after folding in sunlight pressure and a modest level of outgassing. The fit is not perfect because the real sky rarely is, but it is honest and consistent. The second hard fact is that the rate of brightening over the last week is compatible with a rotating body that exposes active vents at repeating times. Step changes do not need intention to make them. They need thermal stress, crust that cracks, and sunlight arriving on schedule. We compress the technical moment so the rest can breathe. The hyperbolic excess speed sits in the familiar range for interstellar passers, fast enough that capture is not on the table, and slow enough that our tracking can sample the curve well. The phase angle from Mars is favorable for shape and coma measurements as the pass unfolds. The Sun object Mars geometry produces periods of reduced glare that our instruments are ready to exploit. Our filter wheels are set, our cadence scripts are staged, and the clock ticks toward a window, measured in hours, not days. Picture a vivid scene to anchor the math. The orbiter slips behind the planet, and the sun becomes a thin ring around the limb. In that artificial night, the visitor stands as a grain of frost with a faint veil, like a lantern hugged close. The track we lay across the stars looks like a taut string that hums without a sound. Each time the guidance updates, the bead of light stays on the string. If it leaves the string, even a little, we will know which way the air moved inside its frozen stone and how hard it pushed. We do not pretend the mind is immune to drama. This is a moment made to feed stories. A traveler from between stars happens to pass near a world that hosts machines with eyes. It brushes a balcony where we happen to be standing. The setup feels like a line written in advance. The logbook keeps us honest. Chance arranges many such scenes because the universe is big and time is long. Our test for planned arrival is not how the story feels, but whether there's work being done that cannot be paid for by ice, sunlight, and gravity. There is a grounded speculation that earns a place here. If the nucleus carries patches of carbon dioxide ice that sublimate at lower temperatures than water, then activity can switch on early and in a lopsided way. If the spin axis is tilted so that a jet points into sunlight at a certain interval, the small thrust will repeat like a heartbeat. To an impatient eye, a heartbeat looks like a signal. To an instrument, a heartbeat says rotation plus outgassing. We let the instrument have the first word. We test for stealthy pushes with a simple method. Fit the track for gravity alone. At a standard radiation pressure term, scaled to brightness and distance. Include a non-gravitational term that captures the gentle shove of gas leaving the nucleus. Then look for the leftovers. If the leftovers fall to zero within our uncertainties, we keep walking down the corridor of ordinary physics. If the leftovers persist, we tighten the model and ask for more data. Only after the tightest model we can honestly build leaves a residue do we entertain stronger claims. A brief tour of the forces keeps us centered. Gravity here is a duet between the Sun and Mars. Light pressure is a soft hand that pushes dust and, through dust, can nudge the track. Outgassing is a whispering thruster that turns on where sunlight warms, fractures, and pores. All of these are small compared to the main pull, but none can be shrugged off if we want the curve to tell the truth. The good news is that small forces have specific fingerprints. They depend on angle to the sun, on spin, on the pattern of active vents. Those dependencies are the handles we use to separate intent from chemistry. Another image, brief and plain. On a table that vibrates just enough to remind you it is alive, the printed map of Mars is taped in place. A thin red thread stretches from one corner to another. Pins mark our predicted positions at equal intervals. A transparent film with a star field lays on top. As new measurements arrive, we set a tiny marker on the film. The markers land on the thread often enough that we do not lower our guard. We lower our shoulders and keep working. We keep our promise to avoid premature drama while leaving room for wonder. The path so far is the path any interstellar comet would trace under these conditions. That does not empty the sky of meaning. It fills it with a quiet reassurance that the same rules work here that work everywhere else. If there is anything more, it will not need a raised voice to be heard. It will show up as a number that refuses to be explained away, as a line that bends the wrong way. After every correction, we know how to apply. We close this entry with a practical note rather than a flourish. The next slot in our schedule is a high cadence imaging sequence during a brief reduction in glare, followed by a polarimetric sweep that catches a slightly different scattering angle. The plan is plain, the timing tight, and the math ready to listen. The curve is still a curve, clean and spare. We follow it where it goes. The room is as small as a heartbeat. Racks breathe softly. A red limb curves through the window, then fades as the craft turns its face to darkness. Inside, everything slows and tightens. The watch begins long before the light arrives. We start with temperature. Cameras do not earn trust until they are cold and steady. Heaters step down in tiny increments. Radiators drink heat into black space. The focal planes settle until their drift is smaller than the noise they measure. Bias frames, dark frames, flats against star-rich fields, black on black, then gray on black, until the patterns that belong to the instrument are mapped and can be subtracted from the sky. Cooling buys sensitivity. Calibration buys honesty. Pointing follows. Reaction wheels spin up to a measured whisper. Thrusters stand down to keep the frame free of jitter. The star tracker paints a net across the sky, and the guidance computer laces the net to our target. We do not simply point. We match rate. The visitor is not still. It crawls a few arc seconds per minute. That motion is fed into the mount, so the comet stays as close to a point as physics allows. Guiders nibble corrections, no bigger than a few pixels. The main camera rides the calm. 2 hard facts go in the log before we let words wander. First fact: clock sync across the instrument suite holds to better than a millisecond, which is enough to stitch exposures into a clean time series and cross-compare light with rate and angle. Second fact: the pointing stability reaches the arc's second class during test slews, which keeps stars neat and makes subtraction clean when we search for the faintest halo around the core. These are not moods. They are numbers we can repeat. Scripts load in order. There's no improvisation when minutes cannot be repeated. The first ladder is acquisition, short exposures, stepped through gain and exposure time to avoid saturation if a burst arrives. Then a cadence that alternates broadband images with narrow spectral slices, each labeled with phase angle and roll. After that, polarimetry. The filter wheel turns through 3 angles, and the camera counts how the light twists as it scatters from dust. At set points, the spectrometer takes a deeper breath to search for lines that sit just above the floor. Water, carbon dioxide, carbon monoxide, organics, if they're brave enough to leave a fingerprint. A vivid image to anchor the plan. Imagine the orbiter drifting into the planet's night. The sun, hidden behind Mars. The sky outside the window turns velvet. With the glare gone, the visitor's halo looks like frost around a pearl. The tail is a brushstroke, just visible at the edge of vision. Tucked into that glow are the letters we hope to read. Grain sizes write themselves in polarization. Gas composition hums in thin lines. The spin of the nucleus hides as a tremor in brightness. We hold still so the words do not smear. Risks are listed without drama. Scattered light from the planet's edge. Cosmic rays stitching bright freckles across the detector. Microvibrations when a wheel is not perfectly balanced. We have counters for each. Baffles and rolls to keep the limb out of the field. Median stacks and outlier rejection to clean particle strikes. Wheel trims to keep the mechanical chorus soft. It is not enough to be ready. The craft must refuse to add its own weather to the sky. To test the leading question with discipline, we build the checks into the watch itself. The light curve will be treated as a signal and a clue. We run an autocorrelation to see whether its steps repeat with a period that matches rotation. We search for non-gravitational accelerations by fitting the path with a model that includes sunlight pressure and a standard outgassing term. We compute the residuals and let them speak. If they vanish with an error, the chemistry carries the story. If they persist after every honest correction, we sharpen our pencils and listen harder. There is a grounded speculation that earns a place on the whiteboard. If the coma is rich in carbon dioxide at this distance, then activity may be patchy and early. That patchwork on a rotating body can look like intent. A vent turns towards sunlight, and the light curve jumps. A thin jet can also fake a hint of control when it repeats at the same body phase. A careful watch does not argue with those tricks. It uses them. A repeating jump pins the spin period. A steady non-gravitational term maps the geometry of vents. What feels like choreography becomes a measurement. The schedule hardens as closest approach draws near. In the hour before the best geometry, we cut exposure times to keep motion crisp. We bracket with short and medium frames so that a sudden surge does not blow the core, while a calm minute does not starve the tail. The polarimetric sweep is repeated at 2 rolls to check systematics. A quick Mars limb occultation of the sun is used to dip the background. For a few minutes, the object will stand in perfect theater lighting. That is when narrow jets, if they exist, will show themselves against darkness. We compress a technical block so the story can breathe again. Telemetry confirms that thermal drifts are below thresholds. The guider loop holds lock through test slews. The spectrometer's wavelength solution is pinned to skylines to within a fraction of a pixel. The polarimetry calibration using standard stars matches last month's values within the scatter. None of this is glamorous. All of it is necessary. We are not here to perform. We are here to measure. The room gets quieter as the scripts reach their last checkpoints. Voices drop to the level of notes written to oneself. A pencil taps twice, then stops. Someone tightens a strap on a laptop as if it matters. Time feels thicker, not faster. Out the window, Mars is a cold ember in a dish of ink. Somewhere beyond the limb, hidden from eyes, but not from sensors. A grain of ancient ice carries its own weather and its own history into the light of a different star. If intent exists, it will not need a shout. It will appear as a small refusal to fit where everything else fits. We have built the watch to catch that refusal and to be satisfied if it does not arrive. Either way, the next sequence opens with precision and ends with something simple and human. A breath held a little longer than usual as the first images land. On the console, strings of letters and slashes crowd a corner of the screen. Discovery tags, survey acronyms, orbit solutions with their tidy codes. The window beside them shows something older than any list, a pearl of light with a wind around it. We let the codes stay small and the wind stay large. Designations serve at the beginning. They make a place on a chart, set a line in a catalog, and help 1,000 eyes look at the same point. But out here, names are scaffolding. What stands after the scaffolding comes down is behavior. Does the brightness breathe with a rhythm? Do jets repeat when the body turns? Does polarized light bend the way dust from ordinary comets does? Or does it argue for grains built in colder, darker nurseries? Those are the questions that stay once the press release becomes yesterday. 2 hard facts first. Free of adjectives. The orbit is not bound. Eccentricity greater than 1. Tracked across many nights. Cross-checked from different vantage points. The path will not close. And the light curve shows stepwise rises that repeat on a timescale compatible with a rotating body that brings active vents into sunlight. These 2 anchor the rest. A traveler passing through, active enough to make its own weather. We compress the technical block so the narrative can breathe. The hyperbolic excess speed sits in the comfortable bracket for interstellar passers. The face angle from Mars gives us a clean handle and scattering, better than Earth would at the same moment. The coma radius grows by a modest, steady fraction each day. The preliminary spin estimate lies somewhere between a few hours and a dozen, with room to narrow later. All of this is enough to stage a careful test of intent, without needing intent to explain anything yet. A vivid image to hold. The orbiter drifts into artificial night as Mars hides the sun. The halo around the visitor brightens by contrast. In the dark, a pair of faint fans lifts from the core at different angles, like quiet hand gestures held just long enough for the camera to learn them. One stream curves away from the sun. Another, thin and austere, seems to point back toward it, an anti-tail drawn by perspective and grain size. If you do not know the trick, You might swear the object was signaling. Knowing the trick does not make the view less strange. It makes it honest. Behavior, not labels, will tell us what matters. We run the light curve through an autocorrelation and watch peaks line up at an interval that may be the spin. We fit the track with gravity, light pressure, and a standard outgassing term, then measure the leftovers. We rotate polarization angles and chart how the signal moves with phase. Each of these is a fingerprint. Names can be changed or misremembered. Fingerprints refuse to be rewritten. There's a grounded speculation that earns space here. The coma appears heavy with carbon dioxide at a distance where water would usually sleep. That suggests surface layers where low-temperature ices sit close to the skin, ready to stir early. Patchy exposure of those layers on a rotating body would make brightness jump as fresh patches turn sunward. If the spin axis is tilted, a thin jet could repeat like a heartbeat. The mind reads heartbeat as message. The instrument reads it as torque and timing. We let the instrument speak first. Labels still help when we cross-talk with other eyes. A catalog line makes it possible to compare measurements gathered by very different machines, under different skies, with different noise. But the center of the conversation is not the name. It is the behavior that survives translation. A deep negative branch in polarization at small angles. A CO2-dominated breath when water is quiet. A clean hyperbola with non-gravitational accelerations that sit where chemistry says they should. These are sentences any observatory can read aloud. We watch for the unglamorous failures that fool even honest observers. Flat field errors that mimic halos. Guiding hiccups that smear jets into fiction. Calibration drift that turns one color into another. The scripts we run fight each of these in turn. Flats under star-rich fields. Guide loops that refuse to chase hot pixels. Standard stars to pin the color scale. No single step makes the data pure. The stubborn layering of steps makes it trustworthy. A short cluster of numbers. Then we put them away. Closest approach to Mars sits near 30 million kilometers. Near for astronomy. Far for any notion of rendezvous. The usable window spans hours, not days. The cadence sharpens to seconds when the geometry peaks. Polarimetric sweeps land at 2 rolls to catch systematics. Spectra step through bands where carbon species sing, then rest long enough to let faint lines rise above the floor. That is the tempo of real work. We put older visitors on the table, not to chase drama, but to set a scale. One had the restraint of a stone with no obvious breath. Another threw a plume like a standard bearer. This guest sits between those examples in some ways and far from them in others. The comparison helps us keep our voice even. There is no single mold for travelers from outside. Variety is the rule. Surprise is common. Evidence is the only referee. The word arrival keeps its charge even when we strip it of romance. Any flyby near a planet is an arrival of sorts. Planned arrival is another thing. It asks for motive, energy, and navigation that leave marks you cannot scrub out. If those marks exist, they will show up as pushes that do not match sunlight and gas, as timekeeping too precise for spinning ice, as structures that ignore the heat budget, written into physics. We look for those marks because the question deserves the courtesy of a real test. We accept their absence because reality has no obligation to surprise us. Names helped us find the thing. Behavior will let us understand it. The window tightens. The scripts harden. The craft turns one more time into the quiet where measurements live. Out the window, a grain of ancient winter writes its brief autobiography in light, and every instrument on the rack leans in to listen. The first image of the watch comes down with the hush of snowfall. A point brightens, stalls, then brightens again, as if the visitor were counting under its breath. On the monitor, the light curve rises in neat steps, terraces cut into a slope. It looks like intention. It feels like code. We set feeling aside and sharpen the math. 2 anchors first. The step heights are modest, single-digit percentages to tens at most, and they recur at intervals that match a plausible spin rate for an active nucleus. The phase angle changes across our sequence are small, so forward scattering alone cannot explain the pattern we see. Those facts pin the corners of the page before we start sketching. We compress the technical moment so the story can breathe. A Lom's-Cargill periodogram teases out a broad peak that suggests a rotation somewhere between a few hours and a dozen. Autocorrelation reinforces it. When we fold the light curve on that tentative period, the terraces align more often than chance would permit. That is not a proclamation. It is a handrail. We will refine it with better cadence, near closest approach. A vivid image earns a place. Imagine a dark millstone turning in cold sunlight. Thin plumes lift from cracks no wider than a pencil, invisible except for what they do to light. Each time a vent faces the sun, a faint veil thickens, the coma brightens, and the curve steps up. As the vent turns away, the veil thins and the curve rests on its new shelf. No voice speaks, yet a rhythm emerges. We test the obvious suspects. Geometry first. The phase angle shift across the sequence is not enough to conjure terraces on its own. Particle size distribution next. A fresh dose of fine grains can brighten a coma quickly, then settle to a plateau as larger grains dominate. Venting behavior last. Early carbon dioxide outflow from low-temperature ices can switch on sharply when crust fractures under thermal stress, then stabilize until the next fracture. Each hypothesis is simple. None demands hidden hands. 2 hard facts to steady the pulse. Within our uncertainties, the timing of the steps drifts with a changing view in a way consistent with a spinning body, not a metronome in the sky. And the non-gravitational term needed to fit the trajectory does not jump with the light. It grows gently, as you would expect if jets add a steady whisper of thrust, rather than discrete kicks. Brightness can dramatize. Momentum tends to be dull. We put earlier visitors on the table to set scale without chasing ghosts. One passed with scarcely a breath, its light a lesson in restraint. Another shed dust like a banner in wind, exuberant and familiar. This one sits between those poles, with a composure that makes the small drama of steps more visible. Comparisons take the heat out of words. Variety is normal. Surprise is common. We keep our pencils sharp and our voices level. The coma itself offers a clue written in color. If carbon dioxide dominates at this distance, low temperature vents can create on-off behavior before water joins the chorus. Patchy CO2 frost, a tilted spin axis, and sunlight that returns on schedule will play the light like a simple instrument. The mind hears melody. The instrument registers torque. We prefer the instrument. We guard against unglamorous errors. Flat field ghosts can fake terraces if the target walks across a pattern. Guiding hiccups can smear a faint halo into momentary brilliance. Cosmic rays can dot a frame with false confetti. Countermeasures hum beneath the narrative. Dithers smooth detector quirks. The guider loop holds a lock so tight the stars look engraved. Median stacks and outlier rejection erase the rain of particles. The curve that remains is less pretty and more true. Another image, quick and spare. The orbiter slips through the planet's shadow. The sun is a ring. The visitor is a lantern with a breath. On screen, the curve becomes a staircase again. Not as neat now. A little human. Imperfect. Real. The impulse to read meaning into steps is strong. The discipline to ask whether chemistry is enough is stronger. We climb with care. We test for hidden pushes that brightness alone cannot confess. Fit gravity and sunlight pressure. Add a standard outgassing model that follows the folded rotation phase. Subtract. If a residue remains that keeps its sign and refuses to shrink as our model improves, we will mark that page and return with fresh data. For now, the residue behaves like a polite guest and takes the chair we've set for it. Practical notes. Close the loop. We tighten cadence around the suspected rotation phase to catch the exact rise time of each step. If steps sharpen when a particular body longitude faces the sun, the period estimate will lock down. We will pair polarimetry with each rise to see whether grain sizes change when the light jumps, and we will press the spectrometer to listen for a brief increase in carbon lines that would name the vent's breath. The curve on the wall is still a curve, and the steps on it look less like speech the longer we listen. If there's a message, it is written in the patience of physics. We read on. The first hint is not brightness. It is color. A pale ring around the core takes on an emerald cast, faint at the edge of vision, and then unmistakable, as if the visitor were breathing through a veil of cool fire. The screen shows it plainly when the filters cycle. The continuum stays sober. The narrow band lights up. We begin with the measurement, not the mood. The spectrometer records a rise in the green emission near 520 nanometers. The band most comets paint with diatomic carbon. The increase is modest in absolute terms and clear in ratio to the local continuum. It appears earlier in heliocentric distance than our baseline model would predict if water outgassing were the only driver. The pattern holds across successive exposures with a cadence tight enough to catch small swings from rotation. Second anchor, equally simple. The glow hugs the nucleus. The scale length is short, confined to the inner coma, where molecules that live only hours under sunlight can survive. That is the behavior expected for C2 produced from parent species that break apart quickly, not a glow that should wander down the tail. The geometry gives us an extra check when Mars hides the sun. In that window, the halo brightens by contrast, not by physics changing under our feet. A vivid image earns its place. Imagine the planet below as a dark ruby coin, the horizon a thin collar of light. Above that curve, the traveler drifts like a seed. Around the seed, close and breathing, a light green haze pulses with a slow turn of a distant stone. It is not loud, it is insistent. The color seems to know when a vent faces the sun. We compress the technical block so the story can move. Filters alternate between broadband and a set centered on common comet bands. The green channel is paired with a blue and a red for cross checks. Dithers step the target across the detector to smooth flat field quirks. The guider holds the target to within a fraction of a pixel. Polarimetry sequences ride on the same cadence to see whether grain sizes shift when the green rises. The logs stay dull by design. There is a grounded speculation that belongs here. A coma dominated by carbon dioxide at this distance would favor early carbon chemistry. If the surface carries patches where low temperature ices sit close to the skin, sunlight can switch on gas flow before water begins to speak. Photolysis and fragments from those early gases can feed C2 near the core. So a green halo that arrives sooner than we expect is not a claim of novelty. It is a nudge to adjust the starting mix in our model. Patchy exposure plus spin makes the nudge appear as pulses. We test familiar suspects one by one. Instrumental color drift is checked against standard stars, bracketing the sequence. Scattered light from the Martian limb is mapped and masked. Cosmic rays are scrubbed by median stacks. A weak auroral contribution from Mars would not sit on the target and would not rise and fall with the nucleus phase. So geometry dismisses that path. What remains is a signal that behaves like real chemistry under patient light. Two more facts keep the floor solid. The rise in green intensity tracks a rotation phase that also shows a small, repeatable lift in total brightness, and the timing offset between color and brightness is small. That pairing is the signature of a vent that adds both dust and gas when it faces the sun, and the non-gravitational term in the trajectory fit does not spike during the green pulses. Momentum does not care about our taste for color. It grows with the long average of gas leaving the surface, not with every breath. Comparisons help more than adjectives. We hold the memory of a visitor that offered almost no coma at all restraint and angles. We hold the memory of another that threw off dust like a banner and colored itself according to every rule in the book. This traveler sits between those, yet it leans toward the carbon side of the ledger at an earlier stage. Variety is the rule. Surprise is common. We will not confuse uncommon with unnatural. The human story tries to push in when color looks like signal. A green that turns on and off with a cadence tempts the mind to read alphabet where there is recipe. The countermeasure is time on task. We fold the light curve by the tentative spin. We overlay the color strength by the same phase. Peaks meet peaks often enough to be real, and not so perfectly that we accuse intent. The line through the numbers says rotating vents on an object with an uneven skin. The rest is narrative gravity we do not need. One more glimpse outside the math. In the brief darkness, when Mars eclipses the sun, from our point of view, the halo tightens and the tail thins to a brush mark. The green shines against a field of hard stars. Within that ring, a knife-thin jet brightens for a moment and then softens as the body turns. If we were here only for spectacle, that would be enough. We are here to take the spectacle apart into parts. The universe repeats. We keep an eye on what this color can teach about origin. C2 is not a birthplace signature by itself, yet an early and strong presence, coupled with signs of carbon dioxide driving the flow, points to ices and organics that formed in colder, older reservoirs than the ones that built most short-period comets. Grains that grow and sinter under such conditions can scatter light in ways that push polarization curves into stranger shapes. If those shapes persist in our data, the picture of a very cold cradle gains weight without needing anyone to design it. Practical steps tighten as the window narrows. We schedule a denser sequence through the green band during the hour when the suspected vent faces sunlight most directly. Pair each snapshot with a matching polarimetric angle and extend the red arm of the spectrometer to listen for faint carbon chains that sometimes accompany a strong C2 signal. The plan leaves little room for improvisation. The clock keeps us honest. Drama needs no invitation here. Yet the most dramatic sentence in the room stays simple. The color is early and stronger than expected at this range, and it follows a rotation that fits our other measurements. That tells us to watch closer, not to jump. The screen dims for a moment as the next set loads. We lean in, not to believe, but to see what the next breath of green decides to show. The screen warms with the soft fire of infrared. Visible light tells us where the halo glows. The infrared tells us what it breathes. We lean closer as the spectrometer draws thin lines across a dark field, each one a syllable from ice that remembers a colder sun. We start with the breath closest to the skin. The green halo we tracked sits on chemistry, fed by fragments near the nucleus. In the infrared, the parent voices speak more plainly. Carbon dioxide rises first, a steady line in the neighborhood of 4¼ microns. Carbon monoxide answers farther redward. The pair grows together like two instruments, tuning before the louder orchestra begins. Water is present, but it is quiet. Its lines do not yet swell the way they will when the traveler dips deeper into warmth. Two hard facts go in the log before the mind invents a myth. First fact: the measured ratio of carbon dioxide to water in the inner coma is greater than 1 during this pass, and the ratio changes slowly across our window. Second fact: a shallow, non-gravitational push aligned with the sun vector is required to fit the track, and its magnitude grows smoothly with total gas output. There are no sudden kicks. The numbers walk. They do not lunge. We compress the technical block so the rest can breathe. The instrument runs a cycle that alternates short, unsaturated glimpses of the core with longer, faint, friendly stares at the outer coma. Wavelength calibration is pinned to skylines and cross-checked with a lamp. Thermal backgrounds are mapped with off-target nods. Dithers remove the last of the detector's moods. In each stack, the carbon dioxide feature stands above the floor with comfortable margin. Carbon monoxide clears the threshold less often, but when it does, it keeps time with the same rotation phase that lifts the light curve. Water hums at the floor, then climbs a little as phase angle and distance shift. A vivid image earns a place beside the numbers. Picture the planet below as a red coin sealed in glass. Our craft drifts into the shadow of that coin. The sun is a thin ring. The object ahead is a seed trapped in its own frost. In the infrared, the frost is not silent. It sings in narrow bars, a kind of music only the instrument can hear. Each time a vent faces the sun, the bars rise, and the seed seems to breathe a little faster, not by intent, by heat. We put the physics on the table in one compact handful. Low-temperature ices like carbon dioxide and carbon monoxide sublimate at colder conditions than water. Fractured crusts let these gases escape early, often at distances where water is still locked. When a rotating body exposes a fresh patch, and the flow jumps and then settles, dust entrained by that gas can lift brightness in steps. The thrust from the flow is small, steady, and focused along the sunlight direction after convolution with spin. None of this asks for design. All of it obeys the simple arithmetic of phase, temperature, and surface. There is a grounded speculation that belongs here. The persistent strength of carbon species at this stage hints that the uppermost layers of the nucleus formed in a very cold cradle. Grains grown and sintered in such a nursery acquire textures that scatter light in unfamiliar ways. That would make a deep negative branch in the polarization curve more likely, and would also delay water's dominance until closer to the sun. A skin like that would be alien by birth, not by manufacture, and entirely consistent with an object that wandered in from a different family of worlds. Comparisons steadied the hand. One of the earlier visitors kept its breath to itself and left us with geometry and reflection alone. Another followed the book so closely that every chapter of comet chemistry read itself aloud. Our guest sits between those poles, with a leaning toward carbon that appears early and refuses to rush. Variety is the rule. Surprise is common. We are not here to be surprised. We are here to be accurate when surprise arrives. We test the easy errors. Could scattered light from the Martian limb masquerade as a carbon line? We fit and subtract a limb model built from off-target nods and find the features remain. Could a calibration drift throw the lines into place by accident? Standard stars at the start and end of the sequence return the same wavelength solution within a fraction of a pixel. Could cosmic rays stitch false stripes into truth? Median stacks and outlier rejection wash that rain away. The signal that survives behaves like chemistry, not like a trick. Two more facts keep the page honest. The timing of the infrared rise is slightly ahead of the green pulses when we fold both by the tentative spin. That offset is small and consistent with gas leaving first and dust brightening just after. A natural cause and effect. And the tail morphology remains stable across the sequence, except for the apparent sunward spike that geometry draws. Shape and color change together when a vent faces the sun, then hold. The pattern repeats with enough imperfection to feel real. A short tour of origin follows without romance. Early carbon dioxide dominance does not tell us where in the galaxy the object began, but it does steer us toward colder assembly zones. If the parent disk where it formed kept carbon species near the surface while burying water deeper, then heat would wake the lightest sleepers first. Such layering would also explain why the coma seems overachieving at ranges where most comets whisper. The oddity is not a signature of intention. It is a signature of habit, written by a different winter. We expand the measurement plan as the window narrows. A deeper stare through the carbon bands during the suspected vent phase. A matched polarimetry sweep to track any grain size shift while gas rises. A hunt for faint organics that sometimes ride with strong carbon dioxide breath. We reduce cadences between frames to catch any short-lived line that flares and fades in minutes. The craft is quiet as it works. Inside the room, voices fall to scribbles and small nods. A brief cluster of numbers, then back to night. Closest approach to Mars remains near 30 million kilometers. The usable geometry for our infrared sequence lasts less than half a day. The period where a limb occultation suppresses glare grants us minutes of perfect theater. In that pocket, we see the carbon lines crest once more, then recede. The water lines lift a little higher than before and do not quite hold. The difference is not dramatic. It is steady. Questions are healthy when they sit in the middle of a paragraph and keep their voice low. If the carbon breath stays dominant longer than our baseline predict, facts. What does that say about the depth of water ice and the porosity of the crust? If water rises on schedule and takes the lead, how will the dust to gas ratio change the apparent rhythm of the light? We log both questions and file them under patience. The last frame of the pass comes in with a hush of paper turning. Carbon dioxide still leads. Carbon monoxide keeps time. Water steps forward and then waits. On the wall, the raw spectrum is a comb of thin brightness against a dark jawline. It is not a message. It is a biography told in chemistry and heat. We save the set, close the protective cover on the instrument, and let the numbers cool beside the silent planet. Night on the rim of a red world is a careful kind of darkness. The limb of Mars glows like a thin coin and then slips away as the craft rolls to keep the visitor centered. On the feed, the halo is soft. The tail is obedient to the wind of light. And yet, a thin spike appears to point back toward the sun, as if the traveler were breaking a rule it has no power to break. We begin with the image, and then take it apart. The spike is narrow, pale, and close to the core. It holds a steady angle, even as brightness breathes in small steps. When Mars hides the sun and the background dims, the feature tightens. It is not a glare artifact from the optics, because dithers move the object across the detector, and the spike follows the body, rather than any fixed pixel pattern. It is not an internal reflection from the planet's limb, because the angle of the spike is measured against the sun and the star field, not the window. What remains is a geometry lesson written in dust. 2 hard facts anchor the page. First fact: the spike aligns with the projected orbital plane of the dust grains, not with the anti-solar direction that rules the ion tail. When the phase angle shrinks, the spike grows more obvious, a known behavior of anti-tails seen when our line of sight skims the dust sheet. Second fact: photometry along the position angle of the spike shows a profile that stays shallow near the core and then drops quickly, consistent with larger, slower grains that linger near the orbital plane, rather than fine ions that race away. We compress the technical block so the rest can breathe. The camera cycles between broadband frames and a pair of narrow filters that avoid strong gas lines. Each sequence includes a short roll, a gentle turn that tests whether the spike rotates with the instrument. It does not. Polarimetry rides on the same cadence, sampling 3 angles to watch how scattered light twists. The spike shows lower polarization than the thinner, classic tail, another hint that larger grains, which depolarize more, are in charge along that line. Guiding holds to a fraction of a pixel. Median stacks clean cosmic rays. The pattern stays. A vivid image earns space. Picture a very thin sheet of dust laid like glass through the visitor's path, made by grains shed earlier on the approach. We are looking almost along the edge of that glass. In such a view, the sheet compresses into a bright streak that seems to point sunward, not because dust flies toward the sun, but because our sight line cuts the sheet at a small angle. The tail that physics demands is still there, streaming away from sunlight. But the sheet is a second brushstroke, laid on the canvas by orbit and time. There is a grounded speculation that fits the evidence. If the object has been venting carbon-driven jets early, larger grains would lift with less speed and stay close to the original path, settling into a thin plane that trails along the orbit of the nucleus. As our vantage from Mars crosses that plane, the stacked grains make a knife edge on the sky. The spike brightens when the rotation carries a vent into sunlight and fades when the plume turns away. Not by intent, by habit. The phase angle geometry then does the rest, amplifying the illusion when the sun, the object, and our craft draw closer to one line. We guard against simpler errors before we allow ourselves poetry. Flat field structure can mimic a line if the target walks across a pattern. We dither and subtract, and the spike follows the object, not the pattern. Guiding hiccups can smear the inner coma into a fake spear. The loop is steady, the stars stay round, and the smear does not appear in frames taken at the same rate on nearby fields. Scattered light from Mars can draw a false gradient. Rolls change the limb's position relative to the optics, yet the spike keeps its place relative to the sun. The simplest tricks have had their turn. They did not pass. Two more facts sit beside the first pair. The spike's brightness falls much more quickly with distance than the main dust tail, a signature of heavier grains that do not travel far from the plane. And the color along the spike is slightly redder than the surrounding coma when measured in our broad filters. Again, consistent with larger particles that scatter differently from fines. Each small clue points to the same family of causes, familiar and honest. We let the instruments talk to each other. Polarimetry says the grains along the spike are less polarizing. Photometry says they fade fast. Spectroscopy, taken in a quiet band, adds a small lift in continuum when the suspected vent faces the sun. The three voices make a chord. In that chord, there is no call for mystery beyond geometry, grain size, and rotation. The mind will still feel a tug toward meaning when a line points against the light. The line deserves our patience, not our projection. Comparisons help more than metaphors. Other visitors have worn anti-tails when the viewing angle crossed their dust sheets, some sharp enough to draw swords in photographs from Earth. Our vantage is different and better in one way. From Mars, the background is quieter and the angle changes more quickly during this pass, so we can watch the spike strengthen and weaken in a single watch rather than over many nights. The change with angle is slow enough to be real and fast enough to measure. That is a gift of geometry, not a sign of purpose. We ask a practical question that instruments can answer. Does the spike swing with the nucleus, or does it stay locked to the dust plane? To test this, we fold the brightness along the spike by the tentative spin period and look for a gentle ripple. A small, repeatable lift appears when the body phase suggests a vent that faces sunlight. The base of the spike listens to the spin, while the far reach ignores it and stays married to the plane. Both behaviors can live in the same picture without contradiction. A brief cluster of numbers, then back to the night. The phase angle during the sequence sat in the teens of degrees, small enough to favor the illusion. The inner spike's full width, at half maximum, measures only a handful of pixels, stable across rolls. The surface brightness along its length drops by roughly an order of magnitude over a few thousand kilometers at the object, while the main tail declines more slowly. None of these values asks for a new category. They ask for a tidy notebook. The scene outside the math is worth a few quiet lines. Mars is a dusky arc. The craft moves like a hand on a slow clock. On the monitor, the spike looks like a notation mark, a small caret pressed into the sky. It points toward the sun because we are looking past the thin edge of a dust sheet. If you did not know the trick, it would look like defiance. Knowing the trick replaces defiance with a traceable cause, which is its own kind of wonder. We end the watch with a plan rather than a flourish. Tighten cadence during the minutes when the vent is expected to face the sun. Pair each snapshot with polarimetry and sample a slightly wider range of phase angles as the geometry changes. If the spike is the edge of a sheet, it will wax and wane with angle. If the base also breathes with a spin, it will rise on schedule. Those two signatures together will turn a clever illusion into a measured property we can fold into the larger portrait. The spike fades a touch as Mars leaves the sun's edge, and the field brightens again. On screen, the halo steadies. The thin line softens, and the long tail keeps its quiet appointment with light. The room leans back, not because the mystery shrank, but because its shape is clearer now, and clarity is what we crossed the night to collect. The craft glides in a night so calm, it feels padded. On the monitor, the halo is a pale lung, breathing in faint steps. Then a fine knife of brightness lifts from the core, tilts a few degrees over an hour, and fades as another blade takes its place. The object is speaking with jets, and the jets are telling time. We begin with what does not care about our expectations. Hard fact. 1. The position angle of the brightest jet repeats within a small tolerance when the light curve folds by a period between several hours and a dozen, which is the signature of rotation rather than chance. Hard fact 2. A shallow, steady, non-gravitational acceleration aligned near the sun line is required to fit the track across our watch, and its growth is smooth, not impulsive, which points to persistent venting rather than discrete thrusts. We compress the technical block so the story can breathe. Cadence tightens to catch the rise and fall of each jet. Short exposures anchor the core without saturation. Medium frames stretch to trace the jet's reach. A rolling sequence at 3 instrument angles checks for fixed pattern tricks. Polarimetry rides on the same rhythm to see how the jet's grains scatter as they lift and fall. The guider holds the point within a fraction of a pixel, while dithers erase the detector's moods. The logs stay plain on purpose. A vivid image earns its place. Imagine a spinning millstone of ancient ice, tilted so the sun strokes one face and then the other. From a narrow crack, a veil streams, translucent as breath on glass. As the stone turns, the veil swings like the beam of a slow lighthouse, painting a circle against the night. When the crack turns away, the beam thins, and a sister veil brightens from a second seam. The sky looks quiet. The clock inside the light is not. Hints of geometry help without stealing the mood. Jets near the subsolar longitude lift dust with the highest speed. Jets near the terminator add a softer plume. When the spin axis is inclined, the same vent faces sunlight at predictable body faces, so our folded light curve stacks little terraces on the same steps. If a vent sits near a pole, the plume traces a cone. Project that cone onto our line of sight, and it draws a slow fan that widens and narrows in a repeating script. We test for traps. Could guiding drift mimic a jet swing? Stars stay round, and the swing tracks body phase, not the guide loop. Could internal reflections draw false blades? Rolls change the optics, but the blade stays tied to the object, not the instrument. Could thin clouds or scattered light from Mars feed a drifting wedge of brightness? Off-target sky frames and limb models remove those ghosts. What remains turns with the nucleus. Numbers cluster briefly, then we let them rest. The folded light curve shows a primary peak and a weaker shoulder, consistent with one dominant vent and at least one secondary. The jet's position angle changes by a few degrees per hour across our window, which fits a rotation in the comfortable several-hour regime. The first moment when the dominant jet faces us, the green band brightens a little ahead of broadband light as gas arrives before dust fully lifts. The non-gravitational term derived from the astrometry grows gently over the watch and keeps its sign, as expected if steady venting is doing quiet work. There is a grounded speculation that earns a line on the board. The rotation may not be perfectly simple. A small precession can make the jet swing pattern drift slowly night to night. If the nucleus carries an irregular mass distribution, the vent torque can change the spin rate by a small fraction over weeks. None of this asks for design. All of it is the plain arithmetic of an uneven stone warmed by a steady star. We schedule cross-checks on later passes to see whether the period slips by minutes, which would be a fingerprint of torque at work. Comparisons steady the hand. A previous interstellar visitor offered almost no visible jets and left us guessing at the body's dance. Another showed textbook plumes that turned the sky into a diagram of comet physics. This guest is generous, but not flamboyant. It lets us read the clock without drowning the frame in dust. Variety is not an argument. It is a reminder that birthplaces write different habits into similar stones. We use the jets to learn more than time. Grain size changes the way polarization swings. as the plume lifts. In our sequences, polarization near the jet base dips a little compared to the surrounding coma, a sign that the grains at launch are slightly larger or more compact. Farther out, as the plume thins and fragments, the polarization rises toward the coma value again. That gradient is a small map of how fragile the lifted material is. If the nucleus skin was sintered in colder reservoirs, grains may be denser, which matches the deep negative branch hinted at in other data. We guard against aliasing, the trap where a wrong period looks right, because cadence conspires. To weaken the trap, we change cadence mid-watch and fold the curve again. The peaks do not slide. We fold independent sequences that were taken when Mars hid the Sun and when it did not. The same body faces emerge in both, even though the background changed. When we cross-correlate jet angle with color strength, the peak lands where the brightest blade also boosts the green band. 3 checks that point to one clock feel dependable. A short passage for the forces at play. Dust lifted by carbon dioxide starts fast and slows as it meets the coma. The largest grains barely leave home and draw short, sturdy strokes. Fines ride farther and stretch the plume. The momentum that matters to the orbit is in the integrated flow, not in the showiest moments. That is why the trajectory term is patient, even when the light curve is jumpy. Brightness speaks in bursts. Gravity and thrust account in totals. What could fool us? Honestly, a second object embedded in the coma would tilt a blade-like feature and move with a logic of its own. We tested for that by searching for a sharp point within the haze that keeps its own rate against the star field. Nothing separated. A shock shaped by solar wind would point away from the sun, not swing with the body face we observe. A rolling mechanical artifact would rotate with the instrument, not with the sky. We crossed each off with a small satisfaction that never rose to celebration. Practical notes. Close the loop. We add a high cadence block, timed to the suspected rotation phase where the dominant jet faces sunlight most directly. We tie a polarimetric sweep to that block to watch the grains at launch. We hunt for narrow jets that only appear when Mars briefly occults the sun, when the theater lighting is perfect. We plan a repeat on the far side of the pass to see whether the clock keeps time after geometry shifts. The room is still. The planet below is a dark ember. On the wall, the folded curve looks like a careful heartbeat, steady enough to trust, imperfect enough to feel real. The jets have taught us the hour hand, maybe even the minute hand. What they have not yet told is who this traveler most resembles among the guests we have met before. And that is a memory worth opening next. Lay 3 photographs on the table under a cool lamp. In the first, a narrow shard crosses a star field with almost no breath around it, more mirror than mist. In the second, a classic banner of dust unfurls, bright and busy, every rule of comet physics written in the open. In the third, a pale lantern glows with a faint green ring and a halo that wavers in measured steps. 3 guests from the same deep road, 3 different habits under the same star. We begin with a tone that numbers set. Hard fact 1. Each traveler rode a hyperbolic path with eccentricity above 1 and speeds too high for the sun to keep. Freedom is the shared signature. The shapes differ in detail, but not in that verdict. Hard fact 2. The present visitor is actively venting at a range where water usually whispers, with carbon species taking an early lead and the light curve stepping in a way that matches a rotating body with patchy skin. Activity is the differentiator, timing the accent. The first photograph is restraint. That object gave us geometry, reflection, and a light curve that hinted at a tumbling shape but offered little in the way of gas or dust. Even its small drift from pure gravity invited multiple natural explanations before any stronger claim could be entertained. The lesson it left was humility in the face of sparse data. When the sky refuses to speak loudly, you do not raise your voice to compensate. The second photograph is exuberance. That visitor behaved like a well-read textbook. Dust poured from vents, gas lines stacked where the spectrograph said they should, and the tail obeyed the wind of light with satisfying predictability. It was alien by birthplace and familiar by habit, the way a stranger can still order from the same menu. The lesson it left was that interstellar does not mean unknowable. Sometimes it simply means far traveled. The third photograph is the one in the console now. The halo is large for this distance and colored by carbon chemistry that usually waits. A thin spike seems to point toward the sun when geometry draws the edge of a dust sheet into a false spear. Jets swing with rotation, painting a clock in the inner coma. Polarization hints at grains that scatter in stranger ways than our garden comets do, as if the skin was sintered under a colder sun. It is louder than the first guest and less flamboyant than the second. It is talkative in its own accent. We compress the technical block so the story can move. In the first case, no coma meant no direct measurement of gas ratios and only indirect inferences about composition. In the second, a strong coma allowed clean detections across the usual bands and dust dynamics that matched expectation. In the present case, the early strength of carbon dioxide lines and the cadence of brightness rises leave enough handles to test spin, vent geometry, and non-gravitational pushes in a single pass. The dataset is cooperative without being generous to laziness. It rewards cadence and punishes assumptions. A vivid image belongs here. Picture the light table again, but now imagine each photograph as a voice. The shard speaks in clipped phrases about shape and reflection. The banner sings loud choruses of dust and gas. The lantern hums in a lower register, repeating a motif of carbon breath and stepping light. None of these voices cancels the others. Together, they widen the key in which the interstellar road can be read. There is a grounded speculation worth writing in the margin. If the present object formed in a colder cradle than the usual short-period comets, its upper layers could carry low-temperature ices close to the surface and grains with compact textures that bend polarization curves into deeper negatives. That layering would wake carbon chemistry early and let jets torque the body enough to shift spin by minutes over weeks. None of this requires a novel category. It is the plain arithmetic of temperature, porosity, and time. Comparisons earn their keep when they cut temptation down to size. The first guest arrived with almost nothing for our spectrometers to eat, which is why narrative pressure tried to fill the silence. The second arrived with so much familiar food that speculation had nowhere to sit. The present traveler lands in the useful middle. It gives enough signal to test ideas and enough oddity to keep us honest. Variety is not an invitation to invent. It is a reason to measure twice. Two more hard facts steady the page. The non-gravitational term that fits the current track grows smoothly with overall gas production instead of jumping with every bright pulse. Momentum accounting stays dull even when light is dramatic, and the phase angle geometry from Mars gives us cleaner backgrounds than Earth would at the same moment, which means subtleties like the anti-tail edge and the inner jet swing are easier to separate from instrument weather. Advantage is not romance. It is a better seat in the same theater. We pull a quiet thread through the three cases. In each, the thing that later felt mysterious was first just a mismatch between what the mind expected and what the instrument recorded. A flat light curve becomes a story about shape because the spectrograph has nothing to say. A loud coma becomes a study in textbook dynamics because the system offers no surprises worth forcing. A green halo that arrives early becomes a lesson in carbon chemistry at low temperatures because the clock and the color turn on the same beat. The pattern across patterns is that careful patience ages better than clever suspicion. Against that backdrop, the provocative thought that framed our mission reads differently. Planned arrival would have to leave scars that do not heal when you add physics. It would have to push where gravity and gas cannot pay the bill. Keep time with a precision that survives every fold of the light curve and exhibit structures that ignore the heat budget that real ices must respect. The first traveler did none of that. The second had no reason to. The present one, under scrutiny, sharper than either predecessor enjoyed, has not asked for such an explanation. It has asked for time, cadence, and cross-checks. We are not done. Echoes do not end the conversation. They let you tune your ear for the next phrase. We carry forward the humility from the quiet shard, the satisfaction from the textbook plume, and the discipline from the lantern that breathes in steps. Together, they set the posture for what comes next, which is to use every advantage our vantage offers, while the window remains open. Mars turns below like a banked coal. The halo ahead holds its greenish whisper. The clock in the light keeps time well enough for instruments to dance with it. We have laid our three photographs side by side and marked what each taught. Now, we turn back to the window and use the gift in front of us. Mars turns below, like a banked coal. Its rim, a thin ring that breathes light, and then swallows it again as the spacecraft slews. In that quiet geometry, the visitor ahead is not just brighter, it is easier to read. The planet is not the subject, it is the lamp, the curtain, and the balcony seat that make the stage make sense. Begin with a picture. When the orbiter slips into the red world's shadow, the sun becomes a narrow crown around the limb. The sky outside the window goes velvet. Stray glare falls away. The coma tightens, and the tail resolves into textures that look like brush strokes laid on glass. Jets that were vague in daylight sharpen into blades. Color that seemed like mood becomes measurement. This is theater lighting, written by celestial mechanics. 2 hard facts anchor the praise. First fact: from Mars orbit, we work at phase angles that Earth could not deliver on the same day, which changes how dust and ice scatter and lets polarimetry separate grain sizes with less guesswork. Small angles deepen the view of the anti-tail sheet. Slightly larger angles strengthen the forward scattering that reveals the finest grains. The same object under a different angle is not the same data. Second fact: the planet can occult the sun for us. A short, predictable eclipse lowers the background by a large factor for minutes at a time. In those pockets, narrow jets that hide in glare step forward, and faint spectral lines walk above the noise. We compress the technical block so the rest can breathe. A single cadence alternates 3 modes. Broadband images trace shape. Narrow filters ride the known comet bands. And polarimetry turns its wheel in a repeating triad. During Mars' limb eclipse, exposure times shorten by design to keep the core unsaturated while the halo brightens by contrast. Off eclipse, the cadence stretches to gather enough photons for the spectrometer's longer stare. The guider keeps the point pinned to within a fraction of a pixel. Dithers smooth the detector's moods. The logs read dull on purpose. A vivid image earns the center of the page. Picture a lantern held at arm's length behind a thin scarf. In Earth's air, the scarf flutters, and the lantern's edges breathe with turbulence. From Mars orbit, the scarf is still. The lantern is cleaner. The faint green along its rim does not smear into blue or red. It stands where it belongs. When a vent faces sunlight, the rim thickens like breath on a winter window, and the thickening stays as numbers, not impressions. Parallax is the gift that hides inside the gift. The distance between Earth and Mars gives us a baseline tens of millions of kilometers wide. Measured against a fixed star field, that separation turns 2 honest sets of astrometry into a 3D path with smaller uncertainties. When we fold in how the light rises and falls, the geometry helps tie a tentative spin to real jets and real non-gravitational thrust. Chance may place a traveler near Mars, but baseline turns chance into leverage. We list what Mars removes as plainly as what it adds. There's no weather to cancel a night. There's no sky glow to lift the floor and drown the faintest lines. There's no noon that cuts an observing run in half. Every minute the craft stays healthy is a minute the plan can keep its promises. The romance in that sentence is just reliability. And reliability is the unsung engine of discovery. There's a grounded speculation worth a line on the whiteboard. If the upper layers of the nucleus were sintered in a colder nursery, then grains near launch may be more compact and less fluffy than many garden comets. From Earth, that subtlety could be buried under atmosphere and glare. From here, with phase angles we can choose and eclipses we can time, the polarization curve that such grains draw has a better chance to reveal its deeper negative branch without confusion from background light. A colder birthplace is not proven by vantage alone, but the vantage cuts the fog that would hide or imitate that signature. Two more hard facts keep this from floating. The non-gravitational term required to fit the track does not care about our seat in the theater. It grows smoothly with total gas output, which is what physics demands if jets are the cause. That behavior holds in Mars' shadow and in ordinary light. And the green emission that whispered near the core rises in step with a body phase that repeats even when the planet's limb is not doing us favors. The seat improves the clarity. It does not invent the song. We let comparisons steady the tone. One earlier visitor offered almost nothing for any vantage to amplify. It was a study in silence. Another obeyed every textbook rule so loudly that any seat would have been fine. This guest is in the middle, which is where a balcony matters. With the angles and eclipses Mars grants, the small dramas stand up straight. And small dramas are where real tests live. Planned arrival would have to leave scars that do not fade when the view gets better. Our better view shows no such scars. It shows ordinary forces doing tidy work. Practical uses follow without flourish. The limb eclipse windows set the clock for our highest cadence, imaging. We scheduled polarimetry to straddle those pockets because the change in background can fool an unwary eye into thinking the grains themselves changed. We timed the spectrometer's deepest stares for the quiet minutes when the sun is hidden and the floor falls. We coordinate with observers at Earth's distance, not for confirmation, but for synthesis. The two seats watch the same play from different rows, and a shared script makes the actors' movements easier to reconstruct. Errors have their own watch list. Scattered light from the planet can creep back in if the roll is not exact. We keep the limb off the optics by a margin written into the script. Instrument flex can shift the wavelength solution by fractions of a pixel when the craft warms and cools. Lamp checks bracket the sequence. Cosmic rays stitch false stars into single frames. Median stacks scrub that rain away. Each small discipline is dull, and each dull discipline removes one more way Mars could fool us into loving our own advantage too much. A brief cluster of numbers, then a return to night. The usable eclipse lasts minutes, not hours, yet it multiplies sensitivity enough to make narrow jets legible near the core. The phase angles we can work here climb and fall by several degrees through a single pass, which lets polarization map how grains scatter without waiting weeks. The baseline between worlds cuts astrometric uncertainty by a comforting fraction. None of these figures is dramatic alone. Together, they are a hinge that lets the door swing open without noise. What remains is the feel of the room when the window is at its best. Voices drop, pens pause. You can hear the tiny hum of reaction wheels and the fainter one of the data recorder. On the wall, a pale glyph advances, pauses, advances again. The red world beneath is a shadowed coin. The visitor writes its autobiography in light, while a borrowed planet turns darkness into a tool in a sky that seems hostile to precision. Mars quietly makes precision easy, and that is why this seat is a gift we use without apology. The scripts are already cued for the next eclipse, the next angle, the next fold of the light where rotation, jets, and chemistry line up. The stage is set, the lamp is steady, and the pages ahead will ask less about what the cosmos allows and more about what our minds try to read into it when it looks uncanny. Night wraps the cabin like velvet. Mars turns below as a dark coin rimmed with a thin ring of fire. On the monitor, a single glyph of light climbs a star field, pausing now and then as if to breathe. It feels choreographed, a cue delivered on time to an audience already leaning forward. The mind loves a pattern. The sky loves a rule. Our task is to separate the two. We start with a frame that facts provide. Hard fact 1. The path is hyperbolic, with eccentricity greater than 1, which means the sun cannot keep this traveler. Gravity writes that verdict in numbers, not in mood. Hard fact 2. The pass near Mars is near for astronomy and far for intent. Roughly 30 million kilometers, with the best geometry squeezed into hours. A rendezvous would live in thousands of kilometers and minutes that lock like teeth. This is not that. It is a glancing visit in a large room. The scene invites another kind of alignment, the one inside the head. A newcomer from interstellar space arrives when two planets are set to provide a balcony and a lamplit stage. Instruments are eager, headlines are easy. A phrase like planned arrival floats to the top because it has rhythm. Bias has rhythm too. The mind hunts for signal and skips past quiet counterexamples that do not sing. Not, we compress the technical block so the story can move. Selection effects come first. You tend to notice a flyby when it passes near a world with eyes, and you tend to ignore a dozen others that slip by far from any convenient camera. Phase angle bias follows. Certain angles amplify features, like forward scattering or the edge of a dust sheet. Those angles make ordinary physics look uncanny, as when an anti-tail seems to point into sunlight because the sightline runs along a plane of slow grains. Last is the look elsewhere effect, the trap where a wide search that tests many timings and alignments will always find one that looks clever after the fact. None of these effects lie. They tell only a part of the truth, unless you count the ways you could have been surprised and were not. A vivid image belongs in the middle of this map. Picture a chessboard in a dark room. A single skylight opens for a minute at a slant, and a piece catches a shaft of sun, bright as a white flame. In that instant, it looks like the piece was placed there on purpose for the light. When the skylight closes and the room returns to even gray, the piece is only where it landed after a long game. Our skylight is the eclipse behind Mars, and the phase angles we get from this orbit. The piece is an icy stone that has not learned our words for timing. We put numbers on the temptation. The rate of brightening has steps that fold on a rotation that is plausible for a small nucleus. That matching cadence feels like intent the first time you see it. It feels like rotation the fourth time you fold it, and the peaks sit where they should, even after the cadence changes. The non-gravitational acceleration fits a model where gas leaves in a steady whisper that tracks sunlight, not a sequence of hidden pushes. Momentum stays dull, even when the light curve tries to be dramatic. Dull is the tune gravity prefers. The mind has other habits that need a gentle check. Confirmation bias enjoys a story about silence from famous instruments, while amateurs post lively frames. It is easy to imagine a hush with a motive when the real reasons are schedules, geometry, and noise floors that punish targets in awkward parts of the sky. It is also easy to string unusual facts into a line and miss the ones that would have bent that line back toward ordinary causes. A good watch list includes both the exciting and the anti-exciting on the same page. We reach for ground that does not slide. Observational cadence shapes experience. From Earth, weather, day, and glare slice the night into uneven strips. From Mars, an occultation turns the sun off like a switch, and the curve of phase angles across a pass redraws the same object on a faster loop. A feature that would take weeks to confirm from one seat will reveal itself in a single watch from the other. That is not a conspiracy. That is parallax, and parallax is the opposite of mystery. It lets two honest pictures become a depth map when you align them well. There is a grounded speculation that belongs here. If the nucleus skin was built in a colder nursery, its top layers could be rich in low-temperature ices and grains that are compact enough to bend polarization curves into deeper negatives at small angles. Early carbon breath, a green inner halo, and steady non-gravitational pushes would follow without any extra hands on the wheel. The unusual parts of the portrait would arise from birth conditions, not from a plan. The timing with Mars would be a gift of geometry and the fact that our machines were awake when the gift arrived. We test the mind with a small exercise. Ask what you would expect to see if the arrival were not planned. You would expect a clean hyperbola, a closest pass to Mars that leaves comfort for coincidence rather than tight tolerances, an activity that follows sunlight and spin with all the raggedness of cracked ice rather than the precision of a clock. Then ask what you would expect if intent were present. You would expect pushes that do not correlate with heat, light curves that keep time across geometry shifts with a fidelity that rotation rarely achieves, and structures that ignore heat budgets measured in energy per second, not in wishes. The watch, so far, fills the first list and leaves the second mostly empty. Comparisons steady the pulse. One earlier interstellar guest had almost no breath. The silence did not signal craft. It signaled stone. Another had a loud voice in dust and gas, exactly where and when the book predicted. The volume did not signal message. It signaled temperature and composition. Our present traveler speaks at a pitch between those two, with an accent that leans toward carbon at a distance where water often waits. Accent is not intention. Accent is origin. We keep a short ledger of errors that can masquerade as meaning. A detector pattern that is not fully removed can turn a steady glow into a ripple. A rolling artifact can make a fan look like a blade that points where you want it to. An untended clock drift can fake a cadence that was only in the instrument all along. The scripts fight these errors in boring ways. Dithers, rolls, flats, lamp checks, guide loops that do not chase hot pixels, and cross-reference with another seat watching the same sky. Boring victories guard the door against exciting mistakes. What remains after the checks is a scene that is still beautiful and still exact. A green ring that arrives early for our taste, but on time for carbon chemistry. Jets that swing on a rotation that stays in the family of hours, not minutes. A tail that obeys light, and a thin spike that only seems to point the wrong way because we are looking along a sheet. Numbers that fit after you pay for gravity, sunlight, and slow gas. The mind can keep its stories. The data keeps its peace. Outside the window, the red coin rolls on. Inside, a line of light crosses a quiet screen and falters for a breath, then steadies. The urge to call it a message softens as the cadence keeps matching the body phase. We are not turning away from drama. We are putting it where it belongs, in the view rather than in the cause. The night ahead tightens into the hours when geometry is best, and that is where the next answers will live. Lights are low, and the plotter glows like a small harbor in night. On one screen, the path of the traveler threads a neat curve across a star field. On the other, a thin row of residuals sits close to zero. Each point, a grain of salt on a dark plate. If anything in the sky intends to hide a secret push, it will have to leave a ripple here. We begin with a ledger that does not blink. Hard fact 1. When we fit the track with the Sun and Mars as the main pulls, include solar radiation pressure scaled to the measured brightness, and add a standard outgassing term, tied to sunlight on the nucleus. The astrometric residuals collapse to small, structureless noise. Nothing keeps its sign across the watch. Nothing grows teeth. Hard fact 2. The required non-gravitational acceleration points close to the sun line and rises smoothly as total gas output rises. It does not arrive in kicks. It does not flip with the camera roll. It behaves like breath, not like thrusters. We compress the technical block so the story can move. We work in a local frame with 3 axes. One axis points roughly away from the sun. One runs tangent to the orbit. One stands out of the plane. The fit solves for small coefficients along those axes and lets the data say which matter. The sunward term walks upward with flux. The along track term is present but modest, consistent with jets that are not perfectly centered on the subsolar line. The normal term sits down near the floor. The numbers are patient. They are not theatrical. A vivid image earns its place. Picture a dancer moving across a stage with a light breeze blowing from the same side of the house. Her dress lifts and tugs in that single direction. Every so often, she pivots and the fabric swings a little ahead of her step. The dance is still hers, but the breeze leaves a trace. That is what we see in the data. Gravity leads. Sunlight and gas tug the fabric. The motion we measure is the choreography you would expect from stone and ice, not from intention. Parallax is more than a pretty word here. The baseline between Earth and Mars gives us depth, not just position on a flat sky. 2 sets of honest measurements from different seats turn the orbit into a 3D track with smaller uncertainty than either could claim alone. When we fold in the timing of the bright pulses and the polarimetric hints of grain size, the small sunward shove lines up with the faces where gas should push hardest. This stitching is plain work. It is also how illusions fade. We guard against traps that make small forces look like stories. Guiding drift can smear the inner coma and bias centroids toward one side, inventing a shove that does not exist. We dither, recenter on field stars, and test with synthetic apertures of different sizes. The shove remains and keeps its direction. Detector geometry can bend positions across the field. Calibrations on star clusters flatten those curves. The bend does not come back. Clock offsets can fake cadence-linked nudges. Cross-checks with independent timing sources kill that ghost. Each small boredom buys one more clean page in the notebook. There's a grounded speculation that belongs on the whiteboard and nowhere else for now. If the nucleus has a slightly complex spin, a small precession could make the along-track term drift over weeks as different vents face the sun with slightly different leverage. That kind of slow wander would not be a code or a message. It would be torque written across an uneven body. We schedule repeats to test whether the rotation period slips by minutes and whether the along-track coefficient moves in step. If it does, a seasonal vent map is the likely cause. If it does not, we tighten the error bars and move on. We keep a compact cluster of numbers and then put them away. The sunward coefficient rises in rough proportion to the gas lines in the infrared. The along-track term is smaller by a comfortable factor and favors times when our folded light curve says a dominant jet faces sunlight. The out-of-plane term hovers near zero with no hint of a trend. The root mean square of the residuals sits where our instrument model says it should when all honest contributors are on the table. None of these values would earn applause in a lecture hall. All of them earn trust. The mind still asks its favorite question: what would undeniable planning look like here? The answer is not complicated. You would see a push that refuses to scale with sunlight. You would see an acceleration that peaks when vents face away rather than toward, or one that anticipates geometry rather than obeying it. You might see a persistent, out-of-plane term that cannot be laid at the feet of any reasonable vent configuration. You would also expect a level of timekeeping in the light that stays crisp as the viewing angle swings, sharper than spinning ice usually allows. None of that is in the room. Comparisons help the pulse stay honest. One earlier interstellar guest drifted so little from pure gravity that arguments about non-gravitational terms were academic. Another wore its outgassing on its sleeve and let the classic sunward shove be measured at leisure. Our present traveler sits between the two, with just enough breath to push, but not enough to overwhelm the fit. Variety across these cases does not strain physics. It enriches the examples you can hand to a student who asks what small forces do. We acknowledge the strongest temptation and set it down with care. The pass near Mars and the neat visibility windows create the feeling of a staged meeting. The fit breaks that feeling on purpose. The sunward push rises when heat rises. The minor along-track bias lines up with vent phase. The cross-track term refuses to become interesting. The dance follows the breeze. There's no second wind coming from nowhere to carry a separate plan. Another image, spare and faithful. The orbiter slides into the planet's shadow, and the sun goes to a thin ring on the rim. The field darkens. The dot of the traveler sits where the ephemeris says it should, within a handful of arc seconds. On the residual plot, the points scatter like dust across a tabletop, indifferent to our mood. A clean fit can be dramatic when the story on television wants otherwise. Precision in quiet light is its own kind of suspense. We end with a practical posture that opens the next door. Keep the cadence tight through the windows when the dominant jet faces the sun. Pair each astrometric burst with color and polarization, so gas, dust, and motion stay tied together. Watch for any slow drift in the along-track term that hints at precession or evolving vents, and keep the threshold for declaring the unexpected where it belongs, high enough that only a number that refuses correction can cross it. When a ledger balances, it is not a letdown. It is proof that the arithmetic of the sky is still the same here as anywhere. Only after the pages stay balanced do we earn the right to ask what true planning would cost and whether any world has ever paid that bill. The cabin is dim, the planet below an ember behind a veil. On the wall, the visitor is a pale seed with a faint wind. If there were intention in its path, if someone or something meant to meet a world and are waiting cameras, what would the sky have to betray? We lay the requirements out like tools on a bench, then see which ones ever leave a mark. Begin with the chore of distance. Interstellar space is not a lake across a park. It is a black ocean that runs for trillions of kilometers. A craft that aimed to cross it and graze Mars on a particular week would need a clock that stays honest for decades, maybe centuries, and a map that updates itself as stars shift by small amounts. That demands navigation that listens to stable beacons, perhaps pulsars, and sensors that can hold attitude to tiny fractions of a degree. Hard fact 1. Every precise arrival writes tiny adjustments into motion over long spans of time, and those adjustments show up as accelerations that do not care about sunlight or spin. Our data so far puts all the small pushes where heat and vents would place them along the line to the sun and in step with a body that turns. Energy comes next, and energy is never shy. To shape a path across that ocean and still thread a pass near a planet, a pilot would either carry a propulsion system or use a gravity and light budget with ruthless efficiency. Carrying real thrust means exhaust, reaction mass, waste heat, or some other signature that rides with the body. No system moves mass for free. Hard fact 2. The non-gravitational terms we measure behave like a steady breath, not like a drive. They scale with gas that chemistry can release at this distance, and they refuse to jump with the brightness pulses as if hidden engines were firing on cue. We keep the technical block compact. A guided arrival at a specific planet within a narrow window needs 3 pillars: navigation, timing, and control authority. Navigation means sensing position and velocity with a precision that survives noise and time, usually through star fields, maybe through radio or X-ray beacons. Timing means clocks that hold phase over many years, so tiny burns line up with geometry when they matter. Control authority means a way to change the path by small amounts, often enough that errors do not snowball, either through thrusters, sails, or venting that is more valve than weather. Every pillar leaves traces, heat, glow, or pushes that do not care about sunlight. Our watch has not met those traces. A vivid image belongs here. Picture a leaf caught in a slow river. Then picture a boat tucked under the same leaf. The leaf drifts where the flat current carries it, with little whirls as water runs around its veins. The boat can slide sideways, hold station, or spin and stop. From a bridge overhead, you read the difference in the wake, in the small ripples that keep a sign, in the lines the water draws when a rudder moves. Our plots are the river seen from the bridge. The wake is a breath, not a propeller. Shielding and survival set their price as well. Interstellar space carries radiation and dust that punish fragile skins. A craft that meant to arrive with sensors awake would need protection for electronics and either self-repair or redundancy that keeps the lights on after years of small strikes. That protection costs mass, and mass asks for energy when course changes matter. With mass and energy come signatures that are hard to hide from the arithmetic. The visitor we watch sheds dust and gas like stone, warmed by light, not like a vehicle that defends systems inside. Stealth is not free in physics. Hiding thrust by making it look like outgassing would require control of venting that beats the messiness of real crusts. You would expect a tight correlation between a chosen cadence and motion, and the kind of clock that stays crisp through angle changes and distances. What we see is the opposite shape: brightness that steps with rotation, a small sunward shove that rises with gas and then rests, and trajectories that collapse to clean fits when gravity, light pressure, and standard vents are in the model. If there's a hand on the tiller, it is letting ordinary forces do all the work. We test the strongest hypothetical with plain numbers in mind, not by carving figures into the air, but by asking what precision looks like on the page. A pass 30 million kilometers from Mars is impressive to a person and generous to coincidence. Precision arrival aims for a few thousand kilometers or less, and near a planet that means minutes that lock like gears. Our windows are hours, and the geometry changes enough across a single watch to let illusions grow and fade in predictable ways. The discipline of navigation would tighten those windows, not leave them as roomy as they are. Communication is part of the bill when intent includes display. A message written in light needs a stable modulator and an audience that can decode without special equipment. The steps we record in the light curve rise when vents turn sunward and ease when they turn away. Fold them by the tentative spin, and they meet often enough to be real, but not with the kind of fidelity that carries symbols. A code that survives distance. An angle is neat and repeatable. Our steps are a little wild at the edges, a little human in their imperfection, a sign of chemistry and cracks, not of duty cycles. A grounded speculation earns a corner of the board. If someone wished to hide intent inside nature, the cheapest way would be to let geology be the messenger. Place low temperature ices near the skin, tilt a spin axis just so, and choose a pass that lets phase angles sharpen the show at one seat over another. That plan still runs into the same checks. The pushes would sometimes ignore heat. The cadence would hold too well across geometry shifts, and the polarization curve would draw shapes that materials under heat budgets cannot support. None of those conditions has taken the room yet. We keep the forces in one short tour, then let them rest. Gravity is the main hand. Light pressure pushes dust and whispers to the body. Outgassing adds a small, steady shove that follows sunlight after you fold in spin. Together, they account for the small swerves when the models are honest and the calibrations are clean. The residuals, the leftovers after fitting, tell you whether a second plan is hiding. Ours sit near zero, like polite sand at the bottom of a glass. What could change this verdict? A persistent, out-of-plane acceleration that refuses to align with any vent map. A brightness modulation that keeps time through angle, changes with precision that rotation rarely maintains. Thermal behavior that ignores the budget written by chemistry, distance, and area. A shift near closest pass that breaks proportionality between gas lines and motion. We have scripts ready for each test as the window narrows, and we will run them without sentiment. The room listens to the instruments more than to any voice. Mars glides through a thin eclipse again. The sun, a ring on a red rim. The field darkens, the halo tightens, and the plots update in steady ticks. The requirements for planning sit on the bench like tools that have not been used, clean and silent. The sky can still surprise us, yet it still prefers to keep its promises. And promises kept are how you tell design from drift. Night holds steady around the racks. Screens glow with plots that look like tide charts, slow and repeatable. The orbiter rides the dark arc above a red world, and a single glyph of light keeps its appointment with the star field. There's no rush in the room. The logbook, thick with numbers and small verdicts, opens to the next clean page. 2 hard facts anchor the first lines. Fact 1. The astrometric fit that includes gravity, solar radiation pressure, and a standard outgassing term tied to sunlight leaves residuals that scatter near zero with no persistent sign. The points do not drift as the phase angle changes, and they do not form the teeth of a hidden gear. Fact 2. The non-gravitational acceleration grows smoothly with total gas output, peaking when the suspected vent faces sunlight, then easing in step with rotation. It behaves like breath in cold air, visible when you look for it, ordinary when you accept what heat can do. The discipline beneath these facts is not glamorous, which is why it works. Clocks across instruments stay within a millisecond of one another, enough to stitch brightness and motion into a single story. Guiders hold stars in round points, while the visitor walks its slow line. Dithers wash away detector moods. Flat fields and dark frames keep the camera from smuggling its own weather into the sky. Each step is dull by design. Each dull step, another lock on the door that keeps drama out. A vivid image belongs early, so the math can breathe. Picture the orbiter entering the planet's shadow. The sun shrinks to a narrow ring on the rim. The background falls like a curtain. The visitor, a pale lantern, brightens by contrast and draws a thin blade from its core, a jet that swings through a small arc as the body turns. In that pocket of quiet light, the line sharpened by eclipse, the instruments read the letters in the halo like a careful hand at a window, breath by breath. Cadence does the heavy lifting. A tightened sequence folds the light curve and finds the same crest again, slightly imperfect, real. A matching polarimetric sweep samples 3 angles, and the dip near the jet base repeats by a small, honest amount. In the infrared, carbon dioxide rises first in the same minutes, carbon monoxide follows, and water leans forward without yet taking the lead. Each channel, kept in its lane, draws a stroke that overlaps its neighbors. The overlap is where confidence lives. We compress the technical moment. The reference star field pins plate solutions to a fraction of a pixel. The spectrometer's wavelength scale is checked at the start and end of each run. Lamp exposures bracket the deep stairs. Scattered light from the Martian limb is measured in off-target nods and subtracted with a model that leaves no structured residue. Polarimetric calibration with standard stars falls within last month's values. None of this reads like a headline. All of it reads like a promise kept. There is a grounded speculation that earns 1 square on the whiteboard. A small precession may be present. The jet's position angle shifts by a fraction of a degree more than rotation alone would explain across several watches. If true, torque from asymmetrical venting is slowly changing the spin state. That would be a natural consequence of uneven crust and low temperature ices close to the skin. It would also nudge the period by minutes over weeks, a change small enough to hide inside lazy cadence and large enough to matter if you are patient. We are patient. Comparisons used gently. Keep the tone balanced. An earlier interstellar shard resisted every attempt to extract gas and dust, leaving only geometry and reflection. A louder visitor, more textbook, filled spectrographs with lines and drew tails that obeyed light like a flag in a steady wind. The traveler in our frame sits in the middle. It has given us rotation, vent geometry, a carbon-leaning breath at a distance where water usually rights first, and a modest sunward shove that accounts for every swerve when you let it. Variety across these cases is not a problem to fix. It is the data set we came for. The logbook does not hide the temptations that keep walking in. The steps in the light curve look like code on nights when fatigue makes pattern hunger easy. The anti-tail points sunward when geometry lines up, and the eye still wants to call it defiance, even after the model explains it. Schedule gaps on other platforms feel like silence with a motive until you factor in angle, glare, and the physics of pointing time. The answer to each temptation is the same: cadence, parallax, and checks that survive a roll of the instrument or a change in background. Numbers, clustered ones, then set down. Closest approach remains near 30 million kilometers. Near for astronomy, far for rendezvous. Phase angles shift by several degrees in a single pass from this seat, which turns a week of Earth based waiting into an hour of clean leverage. The coma's apparent radius grows by a modest fraction each watch. The rotation period estimate sits in the family of several hours and drifts within the uncertainty you would expect if torque is real. The non-gravitational term scales with gas lines and refuses to become interesting when brightness alone is being theatrical. The ledger balances. We give the instrument a moment of personality, not to romanticize it, but to forgive it the labor. The data recorder hums softly, a sound you only hear when the room gets very quiet. A pencil taps once, stops, and does not apologize. Someone tightens the strap on a laptop out of habit. On the wall, the folded light curve looks like a careful heartbeat. The polarimetric points sketch a curve that leans toward a deeper negative branch than garden comets often show at small angles. None of it is shocking. All of it is specific. Risk lists are short when the watch is honest. Cosmic rays still paint false freckles that median stacks erase. Scattered light still tries to sneak in at the edge of the frame, but the roll keeps the limb out of the optics. Internal reflections are checked by rotating the instrument and watching the sky stay put while the camera's ghosts slide away. The remaining failure mode is the oldest one, our own desire to be surprised. The logbook is an antidote to that desire. It lets number after number place its small weight on the same side of the scale until the pan settles. What remains for this entry is posture. Keep the periods tight around the suspected vent phase, then lengthen them for the quiet minutes that help the floor fall. Pair each astrometric burst with color and polarization, so gas, dust, and motion do not drift into separate stories. Cross-reference with Earth-based seats when the angles help rather than confuse. Chart the possible precession with enough humility that a week from now, we can throw the fit away if the line does not hold. The last image we allow ourselves is the one that keeps returning. Mars. A dark coin with a thin ring. The visitor. A lantern with a veil. A jet lifts like a blade, swings through a small arc, and softens. The curve on the wall climbs a notch, rests, climbs again. The numbers behave. The instruments keep their promises. The logbook, calm and a little stubborn, leaves its page open for the next entry, where the molecules that carry the oldest story in this light will have their turn to speak. The room dims, as if to hear better. On the screen, the spectrum is a quiet city at night. Windows lit in orderly rows. Each line is a window that opens onto the nucleus, and the air that spills out tells us where this traveler learned to breathe. We begin with what does not bend to mood. Hard fact. 1. During this watch, the inner coma carries more carbon dioxide than water by a comfortable margin, and that balance changes only slowly across our window. Hard fact 2. Carbon monoxide rises with the same rhythm as the light curves steps, while the green band emissions that come from short-lived fragments hug the core and fade within a short distance, which is the signature of fresh production under sunlight, rather than glow drifting down the tail. Technical work happens in a single, compact moment, so the narrative can move. The spectrometer alternates quick peaks that avoid saturating the core with longer, deep stares that listen for faint lines. Wavelengths are pinned to sky references. Off-target nods map and subtract thermal backgrounds. Dithers smooth detector quirks. Polarimetry rides on the same cadence to catch how grain size shifts when gas rises. No flourish here, only scaffolding that keeps the measurements upright. A vivid image takes its place. Imagine the orbiter sliding into the planet's shadow. The sun shrinks to a thin crown, and the halo tightens like breath caught in a cold room. In that velvet pocket, the spectrum brightens where the carbon species sing. A vent turns toward daylight, and lines lift in a slow chord. A minute later, the light in broadband catches up as dust rides the plume. There's no code in the glow, only a rhythm that heat and spin have used for eons. Chemistry makes plain promises at these distances. Low temperature ices wake first. Carbon dioxide opens the door. Carbon monoxide follows, and water takes longer to speak. Patchy layers, stitched by an older winter, mean some patches answer the sun sooner, and rotation pulls those patches in and out of day like a wheel bringing spokes to light. The small thrust that gas gives the nucleus grows with total flow. The path does not need hidden hands to explain its small deviations. Breath does enough. The molecules also carry hints of birthplace. A carbon-heavy start at this range points to skin assembled in a colder nursery than the one that baked most short-period comets. Grains that formed and sintered there tend to be compact, which bends polarization curves into deeper negatives at small phase angles. That shape has been peeking through our data whenever Mars makes the background dark enough. Origin, not novelty, is the honest word for how this reads. We protect the page from easy mistakes. Scattered light from the Martian limb can forge false baselines. So we bracket runs with off-limb nods and watch the structure disappear while real lines stay. Calibration drift can slip windows across the skyline. Lamp checks keep them steady. Cosmic rays stitch bright freckles into single frames. Median stacks wash that rain away. What remains after these chores behaves like gas, not like a trick. Numbers cluster once, then rest. The rise of carbon lines leads the small brightening in the green by a sliver of rotation phase, which matches gas rushing first, dust following. The non-gravitational shove in the astrometry grows smoothly with total gas output instead of jumping with every light curve stare. The coma's apparent radius increases by a modest fraction each watch, while phase angles from Mars give polarization enough leverage to separate fine grains from sturdier launch material. None of this shouts, all of it points. There is room for one grounded speculation, and no more. If the crust's upper centimeters are rich in low-temperature ices layered over deeper water, then the pattern we see will persist until solar heat soaks down. As water takes the lead later, dust-to-gas ratios should shift. Jet fans should broaden, and the light curve steps should soften into slower swells. If the nucleus is slightly precessing under vent torque, the timing of the strongest carbon breath will drift by minutes over weeks. Each of those changes is testable, which is why they're worth writing down. Comparisons help the pulse stay steady. One prior interstellar visitor left us little beyond reflection and geometry, a study in restraint. Another read like a textbook, its chemistry loud and familiar. This guest sits in between with a winter accent that leans toward carbon and a patience that lets us tie gas, dust, and motion without guessing. Variety is not a dare. It is the range of normal when origins differ. We keep a second pair of hard facts to anchor the bottom of the page. The short-lived green emissions remain confined to the inner few thousand kilometers, even when the halo brightens by contrast, which means they're being made now, near the core, not painted onto the tail later. And the color and polarization changes that ride with a suspected vent phase are small but repeatable, which is exactly what you expect from fresh grains launched in pulses rather than any exotic modulator of light. Plans follow in plain language. Titan cadence around the body phase where carbon rises first. Pair every spectral snapshot with a matching polarimetric angle so grain growth can be tracked as fragments age. Stretch the red arm a little farther to listen for faint organics that sometimes ride with strong carbon dioxide breath. When Mars occults the sun again and drops the floor, push exposure times just enough to catch narrow jets that hide in glare under ordinary lighting. Send the clean time series to the astrometry fit so motion, chemistry, and light stay braided. Outside the numbers, the view remains pair and exact. Mars is a dark coin with a thin ring. The traveler is a lantern with weather. Lines rise, settle, and rise again as the spin brings a seam into sunlight. The ledger of small forces balances when gas is allowed to pay the bill. The molecules have said what they can in this geometry, and their accent is clear enough to carry. As the glare strengthens and the path bends toward the bright side of the sky, the instruments will change their dance, and the record will pass from one set of eyes to another without losing its tune. The red world slips beneath us like a banked coal. Ahead, the sky brightens where the sun waits just off the frame. The visitor keeps its patient climb, but the glare is already reaching for it. A slow tide that will wash the small details flat. The stage that Mars gave us is about to dim. The play goes on, only behind a curtain. We begin with geometry that does not negotiate. Hard fact. 1. The solar elongation is shrinking toward angles that drown fine structure in scattered light. At small elongations, jets blur, inner comae collapse into the glare, and even steady photometry turns noisy. Hard fact 2. This is a temporary eclipse by brightness, not a disappearance. As the object slides behind the sun from our seats, the same orbit carries it back out again. The timing is written by the path, not by opinion. The room shifts from observing to choreography. The last high cadence sequence from Mars runs during a short occultation of the sun by the limb, a pocket where the background falls away and the halo sharpens like frost at a window. We squeeze a final polarimetric sweep into that pocket and pair it with infrared snapshots that listen for carbon species. One more time, before the floor rises. Then the scripts loosen, and the craft pivots to housekeeping that only matters when the sky is about to get loud. A vivid image earns its place. Picture the sun as a white ocean and the visitor as a small boat crossing a bright shoal. From deep water, we could see the boat's wake and the angle of its oars. Near the shoal, the water throws glare into the lens. The wake is still there. The oars still turn. But the details flatten under an honest flood of light. Hiding is not the cause. Illumination is. The handoff begins with simple relay points. Mars-based assets close their watches with a burst of short exposures and a last round of calibration stars. The baton passes to coronagraphs and heliophysics imagers that live to look close to the sun. Instruments with occulting discs that carve a dark hole in the glare. Their inner working angles bite the bright ocean so that large-scale structure can be tracked while the object moves through the worst of the shine. Earth-based telescopes stand down except for timing checks and wide-field frames that try for a trace when the sky allows. On the far side of the sun, the plan waits for the first safe elongations to grow. When they do, the baton passes back to longer exposures and deeper spectra. Two more hard facts. Steady the schedule. The ephemeris uncertainty across the conjunction remains small because the track we fitted before the curtain fell needs only gravity, light pressure, and a steady outgassing term. There is no hidden acceleration waiting to throw the object off the map, and the non-gravitational push we inferred keeps its direction near the sunline and grows smoothly with gas flow. That behavior does not become glamorous when the background gets bright. It stays dull, which is what real forces prefer. The checklist reads like a ritual because the ritual works. Clock discipline comes first. All instruments pin their timestamps against stable references, so every late photon still knows when it was born. Flat fields are refreshed on rich star fields, while the target is unreachable, because a good flat is the cheapest insurance in astronomy. The spectrometer's lamp solutions bracket the last deep stairs, so the wavelength scale will still be honest after the machine snap. Polarimetric calibration with standard stars is repeated once more, and the numbers land where they landed last month. Each small task locks a door against noise that loves to enter when everyone is tired. There is a grounded speculation that deserves a square on the board before we go dim. Carbon dioxide and carbon monoxide have led the breath so far. As the object swings through brighter days, water should begin to take the lead. If that happens, dust to gas ratios will change. Jets may broaden, and the little stair steps in the light curve could soften into longer swells. If the nucleus is precessing by a small amount under vent torque, the phase of the strongest plume will drift by minutes over weeks. After the sun gives the sky back, we will test for each shift not by mood, by overlap of curves taken before and after the glare. Risk lives in the margins, and we face it with plain tools. Solar activity can throw particle storms that freckle detectors and shove spacecraft into safe modes. We protect the record by bracketing with more frames than we want, so the median can scrub the rain. We script a narrow set of safe rolls that keep the limb of Mars, when it is in frame, off the optics. We avoid chasing the target too near the sun, where star trackers lose their footing. No single measure is clever. All of them together are a fence against self-inflicted mystery. Parallax keeps its quiet place in the plan. The baseline between worlds will still be there when the object returns to darker angles. Resumed astrometry from 2 seats will turn the path back into a 3D track with small uncertainties. Folded light curves from before and after will tell whether the clock of rotation slipped. If the along track, non-gravitational term drifts, we will map its change against the suspected precession. If it holds, we will let the line stay straight and thank the sky for being boring. A short cluster of numbers, then back to night. The last Mars limb occultation in this window runs for minutes, not hours. Yet the sensitivity it buys lets a narrow jet stand out like a hairline etched in glass. The phase angles we worked swing by several degrees across a single pass, a gift that we exploited while it lasted. The coma's apparent radius climbed by a modest fraction each watch. The green inner glow rose and fell with a phase that matched a suspected vent, and the infrared lines of carbon species led the crest by a small, repeatable offset. The ledger balances on the eve of glare. We allow one question to sit inside the paragraph, rather than at the door. When the sun gives the sky back, what single change would make us rethink the weight we gave to carbon chemistry, rotation, and vent torque? And are we prepared to accept it if the change never arrives? The answer for now is a posture rather than a claim. We are ready to measure. We are ready to keep saying ordinary, when ordinary keeps paying every bill. The room gets quieter as the last clean frames land. Fans whisper. A pencil stops tapping. On the wall, the visitor is already a paler glyph against a brighter field. The last polarimetric points slide into place and sketch the same unusual curve they sketched before, deeper at small angles than our garden comets prefer. Then the screen lightens another notch and the edges blur. We have met this part of the sky before. It is not a defeat. It is a pause. Housekeeping takes over. Logs are closed with times, not adjectives. Scripts for the far side are checked and parked. The craft angles its panels and waits for the safe middle of a bright hour. Outside, Mars is a dark coin with a hot ring. Beyond that ring, the sun spreads its white ocean. In that ocean, a small boat passes beyond the shoal. We will see its wake again when the water darkens. For now, we trust the plan we wrote, while the view was kind. The room carries the hush of work that knows what it is doing. Screens stack like quiet mirrors, each one holding a different truth, about the same pale lantern. Outside, Mars slides along its dark arc. Inside, we lay out the simplest story the sky allows and see whether it holds when every number has its say. Begin with the anchor that does not negotiate. Hard fact. 1. A dust dynamics model that lets grains leave vents with speeds tied to sunlight, and sizes drawn from a common distribution reproduces the tail, the faint sunward spike, and the halo growth within our uncertainties. The sunward feature appears when our line of sight skims the dust sheet, not because anything flies toward the sun. Hard fact 2. A thermal model that wakes low-temperature ices first and lets rotation gate the flow matches the cadence of the light curve steps and a gentle increase in non-gravitational push without inventing any extra forces. We keep the technical block tight so the rest can breathe. Dust is released along 3 candidate vents on a rotating nucleus. Particle sizes span fine to coarse. Radiation pressure sweeps the fines into the classic tail. Coarser grains stay near the orbital plane and draw the knife edge that looks like a spear from certain angles. Synchrones and syndines trace when and what left the surface, and their overlays land where the images say they should. On the gas side, a simple energy balance lets carbon dioxide and carbon monoxide lead, with water joining late. The resulting thrust is projected along the sun line and folded by spin. The fit does not need heroics. A vivid image belongs early. Imagine a millstone of ancient ice turning slowly in cold light. From its seams, flour lifts in puffs. The lightest dust drifts downwind and paints a banner. The heavier specks settle on the table where the stone has already passed. A thin sheet you only see when you kneel and look along its edge. If you move your head a little, the sheet becomes a bright line that seems to point back toward the lamp. The stone keeps turning. The breeze keeps doing what breezes do. That is the picture the models draw when we let them be ordinary. We run checks that a good skeptic would ask for first. Does guiding drift bias the centroid so a fake shove appears? We change apertures and recenter on field stars. The push keeps its direction and scales with gas. Does a hidden period in cadence fold random steps into a false rhythm? We jitter the sampling, fold again, and watch the peak stay put within errors. Do instrumental ghosts paint a stationary blade? Rolls slide the ghosts across the frame, while the true blade holds to the body's phase and the dust plane. Each trap gets its turn. None wins the day. Numbers cluster in one small paragraph, and then we set them down. The dust model that fits best uses launch speeds that rise with sunlight and scale gently with grain size. The sheet that makes the sunward spike is populated by slower, larger grains released days to weeks before our best images, which is exactly when the geometry says they should have been laid. The gas model needs a carbon dioxide to water balance that favors carbon early and shifts slowly. The resulting non-gravitational term points near the sun and grows smoothly, which is what a breath would do. There is a grounded speculation that earns a square on the board. A slight precession can explain a tiny drift in the preferred jet angle across watches and a minute scale slide in the rotation estimate week to week. Torques from uneven vents will do that to a lumpy body. If precession is present, the dust cones should widen and narrow with a slow beat, and the along-track acceleration should wander by a small fraction over the season. Both signatures are testable once the object emerges from glare. Comparisons keep the pulse level. One earlier interstellar shard barely breathed, and the simple model reduced to geometry alone. Another shouted in textbook chemistry and dust. The same framework handled both cases by changing parameters rather than inventing new physics. Our current guest sits between those poles and the same framework, with carbon ices waking first and patchy vents adding torque, lands on the image and spectra without force. Variety across visitors is not an alibi for invention. It is what the model should absorb if it is honest. We let polarimetry weigh in. A curve that dips deeper into negative values at small phase angles can be drawn by compact grains made in colder nurseries. The dust model that fits the images best prefers slightly denser launch material near the vents, then a quick tilt toward finer fragments as the plume thins. When we fold that grain mix through a scattering code, the polarization points swing in the same direction our data has been hinting at, especially during the brief Mars limb eclipses when the background falls. That rhyme between image, color, and polarization is the kind of harmony nature likes. The mind still wants to ask its favorite question. If this were planned, where would the model break? It would break where thrust refuses to scale with heat. It would break where timing holds sharper than a spinning stone allows across different angles. It would break where structures ignore the energy budget that real ices must obey. The tests so far leave no broken place. The fit does not hide bumps by smoothing them. It explains them by rotation, patchwork, and a chemistry that starts cold. Risk lives in boredom as well as in bravado, so we note the limits. The dust size distribution is not unique. Other mixes can paint similar strokes if you juggle launch speeds and timing. The rotation period has aliases that a longer baseline will kill or confirm. The precession hint is small enough to evaporate if glare steals too much of the curve. The honest posture is to tie every future addition to an observable that moves in lockstep across at least two channels. Motion with color, color with polarization, polarization with phase. Practical steps follow without flourish. Carry the best fit forward through the bright gap and predict the width of the dust sheet, the timing of the green pulses, and the slow wander of the along-track term. Hand those predictions to the teams on the far side so their first frames have a target. When the sky darkens again, check which predictions kept their promises. Keep the ones that did. Throw away the ones that did not. Do not apologize to the numbers if they make you start over. The room absorbs the verdict without ceremony. On the wall, the model tail overlays the real one, and the two lines breathe together. The spike that seemed to break a rule turns out to be an edge, seen just right. The steps in light carry the simple heartbeat of rotation and vents. The small shove in motion keeps time with heat. If there's another story hiding here, it will have to show itself as a number that refuses to move when every honest correction is tried. Until then, the simple comet model has the floor, and it speaks in a voice that fits the sky we have. The red world dims to a thin ring, and the cabin takes on the quiet of a theater before the overture. On the screen, the traveler is a pale glyph with a faint wind, steady enough to trust, strange enough to study. We allow ourselves one thought experiment, not as a verdict, but as a lens. If timing were intentional, what would nature have to imitate so perfectly that even a prepared audience could not tell? Start where numbers do not negotiate. Hard fact. 1. The path fits a clean hyperbola with a small, sunward, non-gravitational acceleration that rises smoothly with total gas output. It does not arrive in kicks, and it keeps the same sign as viewing angles change. Hard fact 2. The light curve terraces fold on a plausible spin, and the phase of color and polarization changes. Tracks those terraces within small, honest offsets. Rotation plus patchy venting explains both the rhythm and the mood without needing an extra clock. Hold a single image to the mind's eye. The orbiter slides into the planet's shadow, and the sun becomes a narrow crown. The halo tightens like frost around the lantern. A knife-thin jet swings a few degrees, and in that swing, the green inner glow lifts, then settles, like breath you can see in cold air. It looks like a signal when fatigue is high. It feels like discipline when the plots align. If purpose were present, but using geology as camouflage, it would have to hide in 3 places at once. First, in motion, pushes that sometimes ignore heat and keep their sign in directions vents cannot sustain. Second, in light, modulations that hold phase across changing geometries tighter than spinning ice usually allows. Third, in material, structures that refuse the heat budget written into chemistry and distance. Each category leaves fingerprints. Absence of those fingerprints is not proof of innocence, but it is a weight on the scale that grows with every clean hour. We compress the tools for testing so the story can breathe. A residual analysis that solves for small accelerations along 3 axes will betray any hidden plan that does work where sunlight cannot pay the bill. A phase stability check that folds the light curve under cadence changes will punish any modulation that acts like a metronome rather than a rotating seam. A thermal sanity test that balances absorbed power against emitted heat will flag reflectors or surfaces that behave like engines instead of crust. None of these tests requires belief. only patience and clean clocks. A grounded speculation finds one square of the board. If this is intent without trust, the cheapest gambit would be passive display. Choose a path that guarantees dramatic angles from at least one balcony and trust pattern-hungry minds to do the rest. That gambit still owes a debt to physics. Geometry can amplify ordinary behavior into theater. The antitale that seems to point toward the light. The eclipse that turns narrow jets into calligraphy. Yet the underlying forces remain slow, sunward, and dull. If spectacle were the whole plan, motion would still look like breath. It does. We let comparisons soften the temperature. One earlier visitor was austere, nearly voiceless, where others strained for message. It delivered only shape. Another was exuberant, as if written from a manual, where others sought mystery. It offered homework and got all the answers right. The current guest hums in a middle key. It leans carbon early, draws an anti-tale when geometry asks, and sets a heartbeat in light when rotation wakes a seam. None of that demands a second author. All of it fits a colder nursery and a surface that fractures where winter is still near the skin. Caution also means searching for ways we could fool ourselves. A cadence artifact can counterfeit phase stability. We break cadence on purpose, and the peaks stay near, where a spinner would put them. A detector ghost can ride a blade. Rolls slide ghosts, while the real blade stays tied to the dust plane. Guiding drift can bias centroids. We switch apertures and recenter on field stars, and the small shove keeps its sunward loyalty. Each boring fix makes the room less friendly to romance and more hospitable to fact. Numbers gather for a moment, then rest. The sunward coefficient in the motion fit rises with gas lines rather than with brightness alone. The along-track term is smaller and follows the same body phase as the dominant jet, which is what torque on a lumpy stone would do. The cross-track term refuses to become interesting. The polarization curve keeps dipping deeper than garden comets at small angles. A shape that compact grains from colder nurseries can draw without help. Nothing breaks when the view improves. Pieces that should agree do. An honest what if also asks for a single decisive observation that would move the needle. A persistent out-of-plane acceleration that ignores vent maps would do it. A light modulation that holds phase through large geometry changes with clockmaker precision would do it. A thermal signature that refuses the energy budget would do it. We keep those gates open and marked, not because we expect to pass through, but because a prepared path is the only way surprise becomes knowledge. The human part of the experiment is harder to quantify. Silence from famous mirrors can look like motive when schedules and glare write their own vetoes. A well-timed balcony on Mars can feel like choreography when orbital mechanics simply hand you a clean seat. Bias is not a crime. It is a habit. We counter it with parallax, with clocks, with patience that does not flinch when a beautiful image turns out to be an edge-on dust sheet rather than defiance of light. Practice follows where philosophy ends. Keep pairing astrometry with color and polarization, so pushes, grains, and brightness never become three separate stories. Keep testing phase stability under deliberate cadence shifts. Keep the thermal ledger balanced so reflected and emitted power always pay for the show we see. When the sky brightens and the stage goes behind the curtain, pass the baton to instruments that eat glare for breakfast and pick it up again when night returns. There's room for one question that does not raise its voice. If the simplest model continues to keep every promise as angles change and days pass, what would you accept as wonder? An answer that says, natural but rare, without apology, or a lingering need for a second author, even when none appears. The view through the small window does not settle that question for anyone. It only rewards the posture that measures first, imagines second, and holds both with a steady hand. The ring of light around the planet thins, and the glyph on the screen softens as glare begins its climb. The ledger balances one more time before the curtain. Scripts are cued for when the sky returns. The thought experiment folds back into the logbook as a margin note, not a headline, and the ship hums the same quiet tune it has hummed all along. The planet below is a dark coin, the sun a thin crown on its rim. The traveler holds to its thread across the star field, small enough to hide in the noise, steady enough to trust. We planned for months to fold light, color, and motion into a single sweep. Now the sweep begins. Two hard facts anchor the opening minute. The closest approach, geometry delivers phase angles that step from low teens to mid-20s as the pass unfolds, which splits the coma into zones where fine dust, compact grains, and the dust sheet's edge announce themselves differently, and the elongation stays wide enough for a short Mars limb occultation of the sun to lower the background by a generous factor, turning narrow jets from rumor into structure for a few perfect minutes. Cadence locks in. Broadband frames map the halo and tail. Narrow filters ride the comet bands, with a green channel paired to a blue and a red for cross-checks. Polarimetry turns its wheel through three angles on a repeating beat. The spectrometer alternates quick glances at the core with longer, patient stares that listen for faint carbon lines and water's slower rise. Timing is the spine. Every exposure carries a clock that can sit beside astrometry without flinching. A vivid image belongs early, while hands are steady. Imagine a pale lantern against velvet. From the core, a hairline brightens, swings a few degrees, and thins. Then a sister blade takes the stage. At the same moment, the inner halo glows greener by a small, insistent margin. A color that lives close to the nucleus and fades within a short walk. In the infrared, a narrow bar at 4¼ microns lifts first. Another, farther redward, answers. Water stirs later, not loudly yet, but with intent. The room listens with its shoulders. We compress the technical block so the narrative can breathe. Dithers, smooth detector moods. Off-limb nods build a background model for scattered light and subtract it without leaving structure. Lamp checks pin the spectrometer's wavelength scale. Standard stars bracket the polarimetry so the angle of scattered light means what we say it means. Guiders hold the target to a fraction of a pixel, while rate tracking matches the slow crawl against the stars. None of this is glamorous. All of it is why the next pages will not wobble. The pass lets three disciplines braid into one rope. Imaging sets jet geometry and the width of the dust sheet that draws the sunward spike when our sightline skims it. Polarimetry watches the jet base depolarize a little compared to the surrounding coma, a sign of sturdier launch grains, then sees the curve rise again as fragments dominate farther out. Spectroscopy listens to carbon dioxide lead and carbon monoxide answer with a small head start before broadband light rises, then notes water leaning forward without taking command. The braid holds where it matters most, the minutes when a vent faces the sun. Two more facts. Keep the page honest. The non-gravitational acceleration that falls out of the astrometry points near the sunline and grows with total gas output, indifferent to brightness theatrics. And the folded light curve keeps its tentative period even after we break cadence on purpose, a small test against the trap where sampling invents rhythm. Rotation still explains the terraces. Vents still do the work. Heat still pays every bill. A grounded speculation earns a square on the board. The slight drift we saw in jet angle across earlier watches looks real enough to be a small precession. If torque from uneven vents is nudging the spin state, the preferred plume should swing through a slow beat measured in days, and the along track component of the non-gravitational push should wander by a modest fraction over the season. The past today fixes a reference frame for that test. Angles, phase, and push all caught at once, so the far side of conjunction has something precise to answer. Comparisons steady the hands without stealing the view. One earlier interstellar shard gave nearly no breath. A pass like this would have been beautiful and mute. Another shouted the textbook in dust and gas. This geometry would have been a comfortable confirmation. Our guest is in the middle, a patient voice with a winter accent. The pass does not make it stranger. It makes it clearer, which is a different kind of gift. The Mars limb eclipse arrives like a curtain drawn by a careful stagehand. Background falls. The inner coma tightens. A thread-thin jet near the suspected vent brightens against darkness and sharpens into a blade with a measurable core. In those minutes, the green channel climbs in step with the blade's swing. The infrared bars crest a heartbeat ahead, and the broadband rise follows both by a small, repeatable offset. Color, chemistry, and dust sign the same line. Numbers gather, do their work, and stand down. The jet's position angle changes by a few degrees across the window, consistent with rotation in the family of several hours. Polarization at small phase angles dips deeper than garden comets tend to allow, then climbs along a curve that fits compact grains near launch and finer fragments outward. The dust sheet's edge paints a controlled sunward spike, whose surface brightness falls faster than the main tail by roughly an order of magnitude over a few thousand kilometers at the object. The fit between model and image improves when carbon dioxide's lead over water is allowed to persist a little longer than our first draft assumed. What the past does not deliver is as important as what it does. No out-of-plane acceleration insists on attention. No phase-stable modulation holds sharper than a spinning seam would allow across the angle changes. No thermal behavior refuses the budget written by distance, reflectivity, and area. The data keeps saying ordinary while the view remains rare. Practical steps close the loop. We lock the clock on the folded light curve and tie it to the angular swing of the dominant jet. We update the dust model with grain sizes that match the new polarization points and predict how the dust sheet should thicken after the bright gap. We send the refined non-gravitational coefficients forward as priors for the teams who will pick up the track when the elongation grows. We mark the small precession hint for a sanity check with a far side baseline. The eclipse ends. The room's brightness rises by a notch as the sun's ring widens on the rim. On the wall, the lantern softens back into a glow that invites patience more than praise. The sweep did what it was built to do: braid images, spectra, and polarization into a single, quiet answer. If there was a plan in the sky, it did not need to show itself today. If there was only drift under heat and light, it showed how elegant drift can be when a world lends you a better seat. The cabin dims until instruments feel like lanterns in a cave. The spectrum is a skyline. The color curves are weather maps. Polarization points are small footprints in powder. All of them together are a birth record, written by ice and dust. Two hard facts set the floor. First, the inner coma remains richer in carbon dioxide than water at this range, and that balance shifts slowly, not in leaps. Second, the polarization curve dips deeper into negative values at small face angles than garden comets tend to allow, then climbs along a shape that favors compact launch grains near the vents and finer fragments outward. Both facts argue for surfaces that wake early in cold light and grains that are pressed or sintered in a long winter. A vivid image takes its place. Picture the nucleus as a seed held in a mitten of its own frost. When a seam faces the sun, gas lifts like a soft exhale, and dust rises in grades, pebbles to flower. Close to the skin, the light scatters as if from smooth beads. Farther out, the cloud grows fluffier, and the light twists more easily. What looks like theater is only texture changing under heat. We compress the technical moment so the story can breathe. Broadband colors stay neutral to mildly red, a hint of organics mixed with darker mineral grains. The green band that tracks short-lived fragments hugs the core and fades within a short walk, which means chemistry is local and fresh. The infrared listens where carbon species speak first and hears water leaning forward without taking command. Thermal models that balance absorbed power and emitted heat prefer a low inertia surface that warms quickly when the sun finds it and cools fast when it turns away. None of these metrics is heroic alone. Together, they settle into a portrait. There is a grounded speculation worth 1 square of the board. If the object formed in a colder nursery than most short-period comets, volatile ices could lie close to the skin, and grains could be denser, layered by slow sintering under faint starlight. That heritage would explain early carbon breath, a deeper negative branch in polarization, and jets that torque the body just enough to drift its spin by minutes over weeks. Such a lineage is alien only by birthplace. It does not ask for tools or plans. We add 2 more hard facts that keep romance out of the math. The non-gravitational push needed to fit the track points near the sunline and grows with total gas output, indifferent to whether the light curve is being theatrical. And the folded rotation period holds when cadence is broken on purpose, which means terraces in brightness answer to a seam turning into daylight, not to a clock that someone set. Age wears 2 faces in the data. The surface looks young where it breathes, because cracks open under heat and fresh material arrives in pulses. The upper layers look old where they resist, because low inertia and compact grains point to long residence in cold storage with little gardening. A seed that spent billions of years in a dim pantry and is now exhaling its first true summer is the simplest reading that honors both faces at once. Comparisons keep the tone level. One earlier interstellar guest offered almost no coma, so origin was guessed from shape and silence. Another read like a manual, loud with familiar chemistry. This traveler sits between those examples and leans toward colder stock. Variety across the trio is not a problem for physics. It is a useful spread for inference. We put numbers in one compact bundle and let them rest. Equilibrium temperatures at the observed distance sit near the low hundreds of Kelvin for sunlit patches and far lower in shadow. The coma's apparent radius grows by a modest fraction each watch. The preferred jet angle drifts slightly beyond what pure rotation would deliver, a quiet nod to torque. Color slopes are small in broadband, consistent with mildly reddened dust, rather than extreme organics. None of these lines is a signature by itself. Together, they rhyme. Honest limits matter. Isotopic ratios that would nail birthplace remain out of reach at this brightness and geometry. Mid-infrared features that would shout crystalline or amorphous silicates are too faint to weigh without more time on target. We mark both gaps and hold them without apology. A good log knows which pages are still blank. Origin becomes clearest when motion, color, and scattering tell the same story. Here they do. Early carbon chemistry, compact launch grains, a low inertia skin, and a push that walks with sunlight point to ice that learned its rules in deep cold. The Mars pass, let those voices speak at once. The far side of glare will tell us if water steps to the front and whether the grain mix loosens as the crust softens. If it does, the portrait will age in public. If it does not, the winter accent will keep its claim. We close with posture rather than flourish. Carry forward the period, the jet geometry, and the non-gravitational coefficients as a single bundle. Predict how the dust sheet should thicken and how the polarization curve should ease when water begins to lead. Hand those predictions to the next seat, then audit them when the sky turns dark enough again. The story of age and origin is already legible. The rest is patience, while the same hand writes a few more lines. The glare thins like fog at dawn. The visitor steps back into a darker sky, smaller now, farther, but still on the thread we left for it. The first frames are humble things, grainy and gray, and then the calibration clicks into place. The old rhythm returns, as if it had been waiting just over the horizon. Two hard facts open the page. First, the astrometric track resumes without drama when folded through the same gravity, light pressure, and steady outgassing term that closed our pre-conjunction fit. The residuals sit down near zero again, indifferent to the weeks of bright silence. Second, the folded light curve recovers the same rotation family we left, with the strongest terrace landing within minutes of the pre-gap phase, once cadence and geometry are accounted for. Whatever torques the vents delivered, they did so with the patience of geology, not the precision of a clockmaker. The picture arrives vivid, even before the color does. Imagine a faint lantern rising over a field of hard winter stars. At first, the halo is little more than a smudge. Then a thin blade lifts from the core, swings a few degrees, and softens, and the old heartbeat becomes legible in a new season. The sunward spike is a whisper now, but the dust sheet that draws it is still there, an edge seen at a shallower angle, behaving as a memory of earlier plumes laid along the plane. We compress the technical moment so the story can breathe. The post-conjunction set begins with a cross-calibration against standard stars, then a sweep through broadband and the familiar comet bands. Polarimetry turns its wheel through 3 angles on a slower cadence, trading speed for signal. The spectrometer stretches exposures to listen for carbon species and for waterlines that should be bolder at this stage. Dithers smooth detector quirks. Off-target nods map a darker background than Mars ever gave us. The scaffolding is familiar, and it holds 2 more facts. Steady the hand. The non-gravitational acceleration remains sunward and grows with total gas output exactly where the spectra say gas is rising. It does not spike when brightness alone grows theatrical. And the jet geometry that once hinted at a slow precession shows the same modest drift in angle across nights, a change measured in fractions of a degree that fits torque on a lumpy body rather than any new intent. Grounded speculation earns a square on the board. Water has begun to lean forward. The green inner glow still hugs the core, but the ratio of carbon dioxide to water is easing toward parity. If this trend continues, the coma should thicken more smoothly, and the terraces in the light curve should soften into rounder swells as dust lifts in broader fans. Polarization near the jet base should climb toward the coma value as finer grains dominate earlier in the plume. Each of these shifts is small, testable, and already peeking through the noise. The braid of disciplines comes back together like a muscle remembering a task. Imaging sets the width of the dust sheet and tracks the thin blades as they swing with the body. Polarimetry sketches a curve that still dips deeper than garden comets at small angles, then eases a little closer to ordinary farther from the nucleus, a sign that fragments are taking over sooner. Spectroscopy hears carbon species first by a sliver of phase, then senses water answering with more confidence than before. The slight offsets between gas, color, and broadband brightness keep their old order and measure, which is how you know heat is still paying for the show. We do not skip the ordinary victories. Guiders hold the target to a fraction of a pixel, while rate tracking matches the slower crawl across the field. Lamp checks pin the wavelength scale. Flat fields erase the camera's own weather. Cross-checks with the Mars set align photometric 0 points, so a rise here can sit beside a rise back there without apology. Parallax, once a dramatic baseline between worlds, becomes a quiet tie line that keeps the story continuous. Numbers gather once, do their work, and rest. The rotation period, refit with a new cadence, sits within the old uncertainty envelope, drifting by minutes at most, in the direction our torque estimates predicted. The dust sheet's surface brightness falls a little less steeply than it did in the colder days, which matches larger finds mixed earlier into the plane. The non-gravitational coefficients change by amounts that track the growing role of water. None of these shifts is theatrical. All of them rhyme with the model we carried through the bright gap. We compare without turning nostalgic. A guest that once spoke almost not at all would have stayed mute through a curtain like this, leaving us only geometry again. A guest that once shouted textbook chemistry would have returned with a chorus. Our traveler keeps its middle key. The winter accent softens, not into summer, but into a later spring, where water shares the line with carbon, and the plume broadens its handwriting. Limits belong on the same page as progress. Isotopic ratios still hide beneath the floor, for now. Mid-infrared textures that would confess grain crystallinity remain too faint for certainty at this distance. The suspected precession is still a hint, not a result. We mark each with a clean box and give them time rather than adjectives. Then, the room lets itself notice one more image, a thin eclipse on the limb of Earth's own air, gives a few extra minutes of quiet. In that pocket, the inner coma tightens, the blade brightens, and the sequence repeats. Infrared lines crest first, the green channel lifts next, broadband follows by a breath. The old cadence, in a gentler register, returns like an echo that knows the words. What began on a red balcony now continues from a plainer seat, and the harmony is the point. Different eyes, same physics. Different angle, same order of events. The ledger that balanced before the curtain balances after, with new terms that grow where they should as sunlight warms deeper layers. The story has narrowed to the quiet pleasure of keeping promises, a path that stays honest, a breath that scales with heat, and a lantern that explains itself more fully the longer you listen. The room feels like a workshop at closing time. Tools are wiped, labels straightened, pencils sharpened for whoever walks in next. On the wall, the pale lantern is smaller now, farther, still honest. We begin collecting what worked, what failed well, and what turned drama into numbers. The bottle we fill tonight is not a souvenir. It is a kit. 2 hard facts start the label. First, breaking cadence on purpose during period searches prevented alias traps and returned the same rotation family within minutes across different watches. That repeatability held through changing phase angles and after the bright gap. Second, pairing polarimetry with the exact body phase when a vent faced sunlight produced a small but repeatable depolarization at the jet base, which rose toward the coma value outward. That pattern survived instrument rolls and background changes, and it is the clearest low-level signature that grain size evolves along the plume. We compress the technical block so the story can move. The core watch list is short and stubborn. Keep clocks across instruments within a millisecond. Rate track the target and dither across a few pixels to wash detector moods. Bracket deep stares with lamp checks. Build background models with off-target nods, especially when a planet's limb is in play. Fold light curves under at least 2 cadences and refold when geometry changes. Fit motion with gravity, light pressure, and a standard outgassing law. Then study the leftovers before ideas get adjectives. A vivid image belongs here for the next crew to remember. Picture a lantern behind a curtain of velvet. For a few minutes, a limb eclipse turns the theater lights down. In that pocket, a hairline jet hardens into a blade, and the inner halo glows greener by a measured sliver. If you're ready, those minutes write more truth than hours of ordinary glare. If you're not, they pass like weather. The checklist gains pages where illusions like to live. Anti-tails are dust sheets seen nearly edge on. Confirm by watching brightness along the spike fall faster than the main tail and by seeing polarization, stay lower there. Guiding drift can invent blades, demand round stars in parallel sky frames, and recenter on field stars before trusting a feature. Cadence artifacts can counterfeit rhythm. Change the cadence and watch whether peaks keep their appointments. Detector ghosts rotate with the optics. Roll the instrument and keep the sky fixed. Each small test trades romance for reliability. We bottle a standard 3-lane cadence. Lane 1 is broadband imaging, short and medium exposures, interleaved to hold the core and trace the halo. Lane 2 is narrow bands that ride the common comet lines, with a green channel paired to blue and red for cross-checks. Lane 3 is polarimetry through a repeating triad of angles. Every 10th cycle, add a short infrared stare near 4¼ microns and beyond for carbon dioxide and carbon monoxide, and keep room for water to enter later. When a limb eclipse is available, squeeze the triad and shorten exposures so the jet base does not saturate. 2 more hard facts justify the lanes. The sunward non-gravitational coefficient rose smoothly with total gas output and stayed close to the sunline, indifferent to brightness theatrics. That is the behavior to expect if vents, not engines, are doing the work. And the thin dust sheet that drew the apparent sunward spike brightened when face angles favored edge on viewing and faded as angles changed, an angular dependence that matches a plane of larger, slower grains rather than defiance of light. A grounded speculation earns 1 square of the label. If the next visitor carries a colder nursery in its skin, compact launch grains and early carbon chemistry will likely return. Expect a deeper negative branch in polarization at small angles and a green inner halo that wakes before water. Plan your cadence to catch both at the same body phase and be ready for small torques that drift the spin by minutes across weeks. None of that requires intention. All of it requires patience. Lessons that traveled well are written in plain words. Mars, or any airless balcony, is a gift when it can occult the sun. Use those minutes for the highest cadence and for polarimetry, not for pretty pictures. Parallax is leverage, not poetry. 2 well-timed seats turn a flat path into a 3D track and pin small pushes without argument. Momentum accounting stays dull, even when the light curve is dramatic. Trust the dull parts of the ledger. We include a 1-page flowchart for anomaly claims. Step 1. Test geometry. Could face angle, edge on sheets, or forward scattering explain the view? Step 2. Test instrument. Could flats, ghosts, or guiding write the feature? Step 3. Test cadence. Could sampling create rhythm? Step 4. Test force. Does the residual acceleration ignore sunlight or keep a sign where vents cannot? Only if a candidate survives all 4 does it earn a new name. Most will retire quietly at step 2. Numbers. Gather once, then rest. Target signal to noise goals for the inner green band should exceed modest single digits per resolution element to see phase locked rises without hallucinating them. Polarimetric uncertainties below 1%. Let the jet base dip stand out when phase angles sit in the teens. Astrometric residuals near a small fraction of an arcsecond after rate tracking and dithers are enough to catch the sunward shove without mistaking it for guiding drift. These are thresholds, not trophies. Data etiquette matters as much as craft. Archive raw frames, calibration files, and scripts that built the products. Publish the cadence you used, including the decisions you regretted, so the next team can avoid your ghosts and borrow your rhythm. Tie photometric 0 points across platforms before claiming evolution, and hand off predictions, not slogans, when the object moves behind a bright curtain. The shortest path to trust is a model that keeps a promise made aloud. We end the bottle with a template epigraph that fits on the inside cover. Keep clocks honest. Break cadence on purpose. Pair color with scatter. Fit motion and respect leftovers. Use eclipses as theaters, not as special effects. Expect cold chemistry first and let water earn the lead. Treat every spike as geometry until the numbers refuse. Outside the glass, the lantern keeps thinning as it walks outward. Inside, the kit sits ready for hands we will never meet. The next guest from the deep road will not be this one. It does not need to be. If the procedures survive the journey, the story will still land where it should. The room is quiet enough to hear the tiny motors in the star tracker turn. Mars is a dark coin under us. The visitor is smaller now and a little paler, crossing a sky that has learned our cadence. The question that framed the watch stands where we left it. We take it apart one last time, with the numbers as our hands. Begin with the ground that did not slide. The path fit a clean hyperbola from first sight to the far side of glare. When gravity, solar radiation pressure, and the standard outgassing term tied to sunlight were included, the astrometric residuals fell to small, structureless noise. Nothing kept its sign. Nothing grew teeth when geometry changed. The non-gravitational acceleration pointed near the sun line and rose smoothly with gas output, a behavior that stayed dull even when the light curve tried to be theatrical. Motion obeyed heat and angle. Light refused to act like a clock with a secret. The terraces in brightness folded on a rotation in the family of several hours. When cadence was broken on purpose, the peaks still landed where a spinning seam would bring a vent into sunlight. Color and polarization kept small, honest offsets that matched gas lifting first, dust following, and grain textures evolving as the plume thinned. The green inner halo, strong for this range, hugged the core and faded within a short walk, consistent with short-lived fragments born near the nucleus. Nothing in the light demanded a metronome. It offered a wheel. Chemistry spoke with the accent we came to expect. Carbon dioxide led at these distances. Carbon monoxide kept time. Water leaned forward later, then shared the line. In the moments when a vent faced the sun, infrared bars rose first. The green channel answered next, and broadband followed. That order held before and after the bright gap. The push inferred from the orbit rose with those lines, not with any independent rhythm. Breath did the work. Light told us when. Dust drew its own map. The anti-tail that seemed to point toward the sun sharpened at small phase angles. When our sight lines skimmed the dust sheet laid earlier along the orbital plane, polarization along that line stayed lower than the classic tail and fell faster with distance, both signatures of larger, slower grains. At the jet base, polarization dipped a little compared with the surrounding coma, then climbed outward as fragments took over. Rolls slid the camera's ghosts without sliding the features. Guiders held stars round, while the blade swung with a body phase. Geometry explained the line without asking for defiance. We searched for the kinds of fingerprints intention would be forced to leave. There was no persistent, out-of-plane acceleration that ignored any reasonable vent map. There was no phase, stable modulation that kept time across angle changes with precision that spinning ice rarely sustains. There was no thermal behavior that refused the budget written by distance and area. A pass near 30 million kilometers is near for astronomy and far for rendezvous. The windows were hours, not minutes that lock like teeth. The stage was beautiful. The choreography was physics. Two hard facts that matter as much as any flourish stayed put to the end. First fact: the orbit resumed after conjunction without drama when carried through the same model that closed it, and the small sunward shove kept its proportion to gas. Second fact: the folded period returned within minutes of its pre-gap phase, drifting only by what vent torque on a lumpy body would be expected to deliver over weeks. Geology wrote the changes. Nothing else asked for a pen. There is one grounded speculation we keep because it continued to earn its keep. The surface appears to carry low-temperature ices near the skin and grains sintered in a very cold nursery. That ancestry explains early carbon chemistry, a deeper negative branch in polarization at small phase angles, and a gentle torque that lets jets drift the spin by minutes across the season. It makes the object alien by birthplace, not by craft, and it turns oddities into parameters rather than into categories. The mind likes plans. It likes them most when a balcony is good and the curtain is well timed. Mars gave us an airless stage, clean phase angles, and brief eclipses that lowered the floor. Coronagraphs and heliophysics cameras kept the record alive when glare hunted the small. Together, they made a path through a bright month that would have swallowed 100 subtle truths if we had watched from only one seat. That is not conspiracy. That is parallax, doing its old, honest work. What remains is a ledger that balanced on ordinary forces when every careful correction was tried. The visitor arrived as interstellar stones do, woke along seams when sunlight found a weak skin, breathed early through carbon while water waited, dragged a fine sheet of larger grains along its lane, and let rotation paint a heartbeat into light. Where an illusion threatened, angle and grain size were enough. Where a temptation beckoned, cadence and rolls put it back on the shelf. The question at the top of the page deserved the courtesy of a full test. The answer at the bottom is simple. No, this did not require a plan. Yes, it rewarded a prepared audience. If a different answer ever comes for a different traveler, the gates it must pass are clear. A push that ignores heat. A clock that holds true angle, changes like carved stone. A structure that defies the energy budget. None opened here. The door to wonder does not close when an object is natural. It opens in a different way toward origins and winters we have not walked. We write the last lines in the same hand we started with. Keep clocks honest. Break cadence on purpose. Pair color with scatter. Fit motion and respect leftovers. Use eclipses as theaters, not as special effects. Expect cold chemistry first, and let water earn the lead. Treat every spike as geometry until the numbers refuse. Tonight, they did not refuse. They sang the same plain song, from first sight over a red rim to the far side of glare and back again. Out the window, the planet turns like a coal going dark. The traveler thins to a pale seed on a steady thread. The room exhales. The logbook closes with a quiet snap. Let the light soften. Let the screen be only a cool glow in the corner of the room. What lingers is not the diagrams or the numbers. It is the feeling of a small, patient thing moving under a larger patience, a grain of winter breathing in the light of a different star. Set down the idea that wonder requires a trick. The sky is generous without one. An interstellar stone wandered near a world with eyes. It caught the sun in its seams and turned that warmth into breath, color, and a thin blade of dust. Instruments listened, compared, and agreed. Ordinary became specific. Specific became beautiful. If your thoughts drift, let them drift with it. Imagine the long road it traveled before the first frame, the quiet years between suns, the slow cold that pressed its grains and taught it to wake at lower heat. Imagine the turn we watched, the soft rise of gas, the faint green at the edge, the way a jet swung like the hand of a clock you can hear only when the house is silent. There are other roads like this, and other stones, and other nights, when geometry happens to be kind. When they come, the same simple tests will be waiting, and the same gentle answer will be good enough when it is true. Natural, but rare, strange, and still ours to understand. For now, let the red world fade to ember. Let the seed become a speck, and the speck become a thought that does not need to finish itself. Breathe in, count to 4. Breathe out, count to 4. And let the cadence find its own way into the quiet. You are safe. The night is wide and kind. Sweet dreams.